That's what he's talking about. This is Tom Baccarella from New York Building Technologies Group. He's knows more about this than anyone else I know. I know he's been raising questions with Albany that they can't answer, so that goes in. So anyway, with no further ado, he's going to tell you all about it. And like I said, he knows more about it than anybody else. And if you have questions at the end, he's going to be able to answer.
All right. Good morning. Morning. I have, we just have a speaker going from the back. So how does the volume sound back there? Was good? All right. Grab my presenter. All right, this is not a good start. A clicker. Got it. All right. Can we fill the banner on there, or is that going to stay? All right, so 2025 residential code. I'm not going to tackle commercial at all. Honestly, I haven't even gotten halfway through the commercial code. This code cycle, it's a little bit over the top as far as efficiency and what you need to do. It's also amazingly convoluted and confusing. They're trying to mirror the commercial code, so they changed the name of everything. They changed the way they they even changed how they lay out the book. I mean, just everything is a twisted mess now. I haven't even touched the commercial code. So I know there'll probably be questions about that. You'll have to wait for another day. They just came out with the com check. They just came out with the res check middle of February. It still doesn't work right. I've been back and forth with PNNL Labs, who does the res check, and they're still figuring things out. They like constantly have little errors. A lot of the stuff that's written on it isn't accurate. I talked to them about it, and they said specifically, we're not going to change it. So, you read all of the checkbox items, and it says, oh, you could do this. And they said, well, no, we're incorrect, but you're supposed to follow the code anyway. So ignore the fact that the res check is a mess. It's copyrighted, so we can't use the exact wording. So it's kind of where we're going with this. All right. For some reason, I'm not working again. There we go. Okay. Wonder if I might just be just far enough that it's a problem. I'll stand forward. Okay. First off, All Electric Buildings Act is postponed. That was supposed to happen. I'll kind of talk about electrification towards the end. Temporarily, it is postponed. As of January 1st, it is on the books that you are no longer allowed to have any fossil fuel infrastructure in a building. The only gas you're allowed to have is for exterior use, pool heater or generator. And they're still not so sure about a pool heater. It's not in the code written. It's not in the law written, so they're not quite sure how to handle it. But basically, everything's supposed to be electric. The governor waived it temporarily until the court case is settled. The same day she did that, she also approved a pipeline from New Jersey to supply natural gas for the power plants that they need to build so they can have enough power to electrify. So she's backpedaling on it now because basically, all the people in my business, all the environmentalists and the tree huggers, they were pushing for it. And when the utility finally caught up, New York ISO, who runs the grid, they came back and said, well, you're going to have brownouts in New York City in 2026. You're going to have brownouts on Long Island in 2027. You're going to need this many new power plants. So everyone kind of backed off a little bit on it. So I have a feeling it's not gonna happen anytime soon, but it will happen. It's just gonna be a matter of when. All right, agenda for today. Not in that order necessarily, but I'm gonna go over the code. And then I wanna just go over some kind of best practices, shell, things that I see that on a regular basis go wrong, where people are failing, over and over. Some of the things that are gonna change because of the way the code's set up that you're not gonna be able to do anymore. I'm just gonna kind of tackle a little bit of everything. All right. Couple of disclaimers. One, I don't know everything. At this point, I'm not sure that anyone does, including the people who wrote the code. There are mistakes. There are spots that they wrote them and then realized they worded it poorly, that they're trying to backpedal on. They wrote it, it came out in September, came out in October. It was officially code as of July, 3 months before. Came out, then they realized, started figuring out all the problems with it. January 1st, they made changes to it. So if you buy a code book, this code book is only moderately accurate because there's been changes since these were printed. And there won't be a reprint, you'll only find the changes online. So it's gonna be an interesting one. Okay, other disclaimer, I don't want you to think that I am against efficiency and I'm, this is my house, I put 16 kW of solar on it. I love the idea of solar. I just like it to make sense. So when I kind of complain about stuff, it's just me griping about the system. It's not that I am anti-green, anti-electrification. It just needs to make sense. Okay, the code. I'm going to go through this quickly. I would rather take questions when you think of it than wait and take questions at the end. So just kind of make this conversational. Just, feel free to throw stuff at me. Just really make this, there's not that many people in the room. We could just have a conversation here. Especially when I start going through some of this stuff, I'll see everybody shaking their heads. That's when you should be yelling stuff at me. All right, shell improvements. They went overboard on the shell. They changed total UA. Res check was always total UA equivalent or total UA alternative. Now it's called component performance. You'll see TC instead of UA. Turns out they realized that somebody decided you couldn't call the insulation around the perimeter of a slab UA. You couldn't do the math and say it was, U times area because it's perimeter, not area. So they came up with an F factor, which is always what we use, but we never named it. And because they had changed it to F factor, they couldn't say it's UA, so they renamed everything. Nothing changed, they just renamed. Duct testing is now mandatory always. It doesn't matter if your ducts are within conditioned space, we still have to test them. If it's leaking into your living room, you fail. Again, I didn't write it. Another big one for the contractors, mechanical ventilation all has to be tested. Your bath fan has to move 100 CFM. Your bath fans have to move 50 CFM. Your kitchen hood has to move 100 CFM. If you're using it as ventilation, if it's a powder room with no window, that fan gets tested and probably fails. And then we're talking about tearing sheetrock up. So I'm going to talk about that a bit. Other ones are for the electricians, fan controls, lighting controls, no more light switches. It's like a commercial building. Everything gets occupancy sensors and dimmers and timers. And yeah, I can kind of see that look of horror. That's
On the duct testing, is it just the supply or the return also count?
the whole system.
Even on the returns?
Yes. Returns have to be no using framing as duct.
Okay.
The leakage.
On the leakage, I'm talking about.
The leakage, you still have to test it all. The leakage is now double or triple. depending on the system. I'll go into the details. So you can have a really leaky system, since it's only leaking into the building anyway, but you have to pay somebody to test it. I spent the last 15 years trying to eliminate all my duct testing because it's just the biggest disaster for us. Like it's always just a pain in the ass. Nothing ever goes well. It's time consuming. We've been convincing everybody to spray foam and work within the thermal envelope just so we don't have to duct test. Now they made it mandatory no matter what you do. Yeah, it's one of the things I complain about a lot.
And the 2 kilowatts per square foot, on the commercial is 2.5. I know you didn't want to go commercial, but it is 2 on the residential, not 2.5.
Yes, too. For electric.
Yeah.
Electric heat.
Yeah.
Yeah, you basically can't, that's for electric resistance.
Yeah.
Yeah. You're kind of limited to bath mats at this point. Okay. Second path, simulated performance. This is the other option. I don't know if everyone's even seen it. This is the other option on a res check where you pick what direction all the wall space, you put in the windows and the shading on the windows that no one ever uses because it never works. I've been doing res checks and earth ratings for 16, 17 years. I've never once submitted permitting paperwork with simulated performance. Sometimes we submit final paperwork because it just happens to pass that way, but it's completely random. This time they changed it a little bit. They added mechanicals in. They took it halfway from being a res check, which was just shell, to being a HERS rating, which includes everything. So now they included mechanicals, they included, I think I haven't seen anywhere. They give you a credit for using heat pumps over fossil fuel. They give you penalties for building bigger. What it ended up doing is it was useless before, no one ever can get it to work. Now it's useless and no one can get it to work. But it's way more
What was that last one on the bottom, the last one? So if you're building over 5,000 square feet.
Yeah, and I'll get into that. I don't want to go, there's like a lot of detail, and again, knowing no one's ever going to use it, it'll come up later on. I kind of break these down. ERI path, that's the HERS rating. If you go for ERI compliance, which is energy rating index, which is a HERS rating, you basically take the entire building, plug loads, lighting, appliances, mechanicals. If your entire building is a certain efficiency, you can trade off shell requirements. So you can take 15% off the shell, which is a massive amount. Generally, it should put solar on the roof, and then you don't have to worry about the windows as much. You know, if you're building with a lot of glass, you can get a house to pass really easily, even if your glass isn't great, metal frame glass, if you're covering the difference with solar. So it's an option. They drop the index considerably, so it's a little tougher to get to, but if you're doing solar, it still ends up being reasonable. They kind of changed the math a lot. If you guys work in the Hamptons at all, where they had the HERS rating index or the stretch code for Southampton, this got really convoluted. We'll get into it in a bit. Speaking of HERS ratings, Shelter Island is going to be going to HERS ratings for compliance. I don't know if you got the paper.
No, I didn't hand it.
Basically, the energy, this is not a new thing. Most of the island is on this already. All in Nassau County, Brookhaven, probably the only exceptions, I think, are Islip and Riverhead that aren't. But basically, your HERS rater, whoever you hire, will handle all of the energy compliance rather than the building department. Very similar to nothing changes on the code. It's not like the Hamptons where you have a stretch code and you have to be building more efficient or putting solar on the roof. You're building exactly the same way. The only difference is we're modeling it beforehand and then we're modeling at the end to make sure it still passes.
How's that happening here?
It's happening as of basically now. Well, basically, the way they've configured the ERI path now is so complicated, we're not smart enough to do it. And it's so time consuming because at the end of the job, you have to reconcile all the equipment, all the appliances. And it's just not really doable by us. And that's why we and everybody else are going to requiring, sign off by a HERS rater. Who you're gonna be hiring anyway, because there's really no way to navigate it. So and the idea is that since you're hiring somebody like your building technologies group, they will oversee the process and they're gonna correct it before you they're gonna go through before you close up the walls and verify that you're gonna pass. And then at the end, they submit a document that says, they need energy code, you meet energy code.
Basically, the difference between them is, we do a model, rather than just a res check, we do a full HERS model. Difference in cost is a couple of $100. It's not massive. The only real difference is you get us from day one instead of waiting until you're ready for your testing, because then it's too late. And with this code, it is absolutely too late. If you wait till the end, I'd say your odds of just happening to pass are going to be 5 to 10%. Something's going to be a problem. It's a convoluted mess.
The big reason I think that we're going to it is because the fact that you require testing for all your ventilation, all mechanical ventilation, everybody's going to look at I've got a 300 CFM fan, bathroom fan, that'll be fine. Well, it's not going to be fine because the rating in the book is some idealized thing that doesn't take into account the ductwork. So then you put in the bathroom fan, it's going to be great, and then it fails.
Yeah.
That's why you really need someone.
Well, you're gonna need makeup air for it to do it. You can't do it close to.
Oh, of course, well, no, but that's required.
It is becoming,
That's been required.
I have the book here. If you're light reading, Builder's Guide to Coastal Climates, it's Joe Stiberick, and he has a saying, there's no free thermodynamic lunch. Every time they make something better, they make something worse. And this code was definitely that. There's a lot of worse in this code. A lot of this code is unreasonable. And like a lot of it, as the guy who's making money enforcing it, I think it's ridiculous and I'm trying really hard to get rid of it. It's not practical, but it's code and we're stuck with it. So we're kind of, at this point, we're dealing with it.
Tom, for
Yes.
modular homes, PFS is considered the rater, and for modular homes as opposed to you?
Well, only if he's going to show up on site and do the testing.
Okay,
So
Well,
if you're doing modular homes tend to have a rater at the factory that signs off for Energy Star. If these homes are going to be Energy Star rated, which pretty much all the factory stuff is, they have a rater on site that signs off on the initial rating. The problem with that is somebody still at the end has to do all the testing. You're still going to need a rater before you start, because you'll end up with the same problem. If you wait till the end, then you're guessing. I've been dealing with a handful of the modular companies. At this point, they are still trying to figure out how the code works. And the way that, again, convoluted, they put in specific equipment requirements that change the shell requirements. So depending on what equipment you put in, your shell changes. So if you're at a modular factory, you're assuming that they have to use equipment that meets certain criteria. But again, somebody has to figure that out, otherwise you get to the end of the project. And the difference between putting in a Navian boiler and a Whale-McLean boiler is a pass or fail. If you go with the Whale-McLean because you thought it was better, you'll fail. The Whale-McLean Ultra isn't efficient enough to get enough credits to trade off the shell. So again, it starts, I'll get into details.
Will the town be doing installation inspections?
Yeah, we're gonna do inspections, absolutely. But basically, the way it's gonna work is when you apply, you're gonna have to have, with the permit application package, you're gonna have to have a preliminary HERS rating that's submitted, that's modeling the whole thing. Similar to, but now there's more.
If you look in the packet,
Res check, yeah.
if you look in the packet, there is a preliminary set of documents that you'll be generating instead of a res check. It's basically a res check, only it's a res check on steroids. We didn't just check the insulation, we actually calculated the efficiency of the insulation. We don't just, for the HERS rating, we're checking pipe insulation, we're checking the fans, you name it, it's being checked. It all gets documented. We have a QA people that go over our files to make sure we test it accurately. A lot of bureaucratic red tape.
Basically, there's not gonna be anything more required in
Right.
terms of the documents. We're just requiring a HERS rater who's gonna make sure that you don't fail. Because it's gonna be a lot more expensive if you don't find out till the end.
At the end of the day, we're just following code. The difference is, the same way you'd hire a separate electrical inspector, you're hiring a separate energy inspector. You have to hire them anyway to do the testing. Now you're hiring them from day one as a consultant to make sure you don't have any problems. Yes?
Yeah, I think every house we've done in the last 5-6 years, you would come in before we sheet rock,
Yes.
and we would have a discussion, what do we need to do?
The problem
What's
is,
the difference?
the problem was it wasn't required before,
But we always did it.
and you never had a problem.
No.
You know how many problems I have? How many times I show up and I get a phone call that says, we're supposed to have this certificate.
Oh, so you
Can you
mean,
send that to us?
our meeting was optional, but we made it mandatory?
I kind of push it as mandatory, because if you get to the end of, if we get to the end of the project and I didn't tell you about all of the things you needed to do and you fail, then we're both idiots.
Right.
So, we always push to get a rough inspection done, but it wasn't mandatory.
So if I've done that for the last 5 years, I'm
Nothing's
not
gonna
gonna be
change.
changing
The only thing that's gonna change is the paperwork slightly.
by you.
Yes.
Yeah.
To speak to that, if you clearly have had someone like Tom, who's proactive.
Right.
What we experience a lot in the building department is somebody got somebody to do a res check and they didn't, who knows who it is. And then you get to the end of the job and everything fails and all the walls are closed up because you didn't have someone. And that's one of the reasons we're going to requiring a HERS rater, because a HERS rater has a license to lose. Whereas if, Joe Schmo is doing your compliance issues, there are a lot of people that have had a lot of problems.
I mean, I can honestly say, I get a lot of res checks in, especially for towns that require a HERS rating. I've seen the same res check, identical, from the same architect at least 20 or 25 times. Still the same, his 5,000 and 6,000 square foot East Hampton houses are still the same 600 square foot res check that he's been submitting. So it became boilerplate paperwork, except now at the end, if it's wrong, you fail. So it's kind of important to get it right day one. Okay. We do an energy model, we're just checking for code. But the model is just basically that HERS model became the only game in town for energy compliance. It's the only, we could just simply say we're going to inspect. The problem is the state wants somebody certified, and the only certification is HERS rater, and the only way I can be certified is if I do a complete rating that somebody else can double check me. They kind of want, levels of quality control. Otherwise, is the whole thing required, all of the modeling? We're only complying with code anyway. The rest of it is, you'll get a number that you don't care about. You get a HERS rating index that tells you how efficient you're building it. The upside to it is you do have the option of that ERI compliance now. And if you're building and if you're coastal and you can't get 0.27 windows, because the windows got really tough They're really hard to find. You can trade that off. You're already doing a HERS rating. I traded off for better equipment. I hit the ERI compliance path. I don't have to worry about the windows. I'm putting solar on the roof. I don't have to worry about anything. I just pretty much build whatever I want. So, all right. It includes everything. I mean, HERS rating, we include the distance of the hot water pipes from the hot water heater, how well they're insulated, how much heat gets lost from the pipes, how much heat that adds to the building, how much air conditioning it adds to the building. You name it, it's in there. The testing's exactly the same. Nothing, if you've been getting these done before, we're gonna come and do exactly the same thing. The only exception is now we're adding bath fan and kitchen fan testing. It's just real simple, straightforward testing. But you're not gonna see anything different except paperwork. And then the big difference is at the end, we commission everything and make sure what you finished with still passes code compared to what you started with. That's kind of the part of the HERS rater's involvement, is you change the windows, you send me an email, I change them in the model. You decide on a different boiler, I change it in the model. And we could be sure at the end that everything's still passing. Then we submit the model as approved and passing New York State code. That's what they're taking as energy code compliance from now on. All right, to the code. Prescriptive. I know you can't read that from there, it doesn't matter. Basically what they did is they took climate zone 4, 5, and 6, and they made them all the same. So we are now on the same energy code as Buffalo, Niagara Falls, anything, we're climate zone 6 and climate zone 4 are exactly the same. They realized that adding more insulation upstate would just be impractical. You know, you already have R49, how do you put more insulation than that? The windows are as good as you can buy without going to triple pane. There's nothing else they can do. So they just made us do the same thing, even though we're in what they consider a mixed climate that doesn't get that cold. Problem with it is the energy savings are almost non-existent. You know, you hyper insulate your building, you spend an extra $30,000, $40,000, you save an extra $200 or $300 a year. In a few hundred years, you get your money back. So, you know, kind of my job is to find the most practical way to do that, where you're not wasting your money. And there are definitely ways to do that. Okay. Changes to I'm just gonna start off with prescriptive code. This is, you know, they always talk about you need R49, you need 21, you need whatever those are. It's kind of, we go through all of the prescriptive stuff, and then I say ignore it all, because at the end of the day, everything's a big trade-off. But I just kind of have to go through it so you can at least see where we're starting from.
I just have one quick question, maybe this is for Ray. How is this being applied to renovations, additions, pre-existing, like?
They're gonna get to that. Unfortunately, there are certain requirements now to bring things up. If you change siding and windows, you have to bring that wall up to current code, which is potentially awesome.
Let's just say that additions and renovations are really tricky with the code. And a lot of the workarounds, like it used to be, the old code used to say, if you added an addition and the finished product with the entire house didn't use more energy than the house used before, you passed code. Great way if you had to finish a basement. Actually, I have used that a handful of times on Shelter Island to bring into compliance a conditioned basement or a garage conversion. Because the way the code read, it said if you finish the basement and the house and the entire project uses less energy before than it did before, so you finish the basement, you didn't put enough insulation in, it's failing, but you throw some extra insulation in the attic, at the end of the day, the house is more efficient, you pass. That's all gone. So now your addition has to meet the new insane code. Let me get into it, but yeah, as for compliance, there's no HERS rating, that's for dwellings only. So that would just be, however you're handling the inspections, however that gets set up, but a lot of the same bells and whistles still apply. Okay, windows went to 0.27. 0.27 is about the best double pane window you can buy as a whole, area weighted average. You might be able to get, your picture window might come in at 0.26, but your doors might come in at 0.28. I talked to all the reps, Anderson, Ella, Marvin. They have like special glass that'll get you there, but they're still worried about how to do it. And again, I'm going to get into this a little bit more. Skylights went down slightly. Walls went to R30 from R20 or R20 plus 5. They're really pushing for continuous insulation, which is fine if you're doing vinyl siding or if you're doing, board and batten. Really tough if you're doing shingle style or something, wood. We'll get into that too. Floors went from 19 to 30. Foundations went to 19. This is the one that has the least effect. Your foundation's underground, the extra insulation does almost nothing. I couldn't get it to move the needle on the energy use.
So with the superior wall foundation, they've got the R12 and the R21. Are you saying now I can't use the R12, it's gotta be the 21?
No. I'm saying that's what the prescriptive says, but you're doing a HERS rating, so everything's a trade-off, everything's up in the air. So again, don't get caught up in any of this yet. By the time I get to the end of it, you'll go, then why'd you waste my time telling me what all the rules were if we don't follow any of them? Okay, slab on grade, R10 for 4 feet instead of 2 feet. No big deal. You bring it down, you bring it in. It just went to an extra 4 feet. It used to be 2 feet, so you just had to go down the foundation. 4 feet's a little more problematic now because if you don't go down 4 feet, you have to come in to make up the difference. So it's just a little bit more of a pain in the neck. Of these, and then heated slabs have to be completely insulated under roll. Well, that was in the old code that way. Now it used to be R5, now it's R10. That's slab on grade, not basement slabs. The big ones that we care about, the windows, this was a massive change. The walls is an absolute nightmare change. The floors was a trade-off. We always put R30, like I would always model R30 in the floors. And you pick up enough by putting R30 where you're supposed to be 19 that you drop the attic from 49 to 30 or 34. So it was always a good place to trade off. The trade-off is gone. Okay, windows. Couple of ways to get there. The triple pane windows, if you buy European, they tend to come in like 0.2 or so. If you're buying 1-inch glass pane, 1-inch spacers and glass, like big door units, those tend to come in under 0.27. If you're buying Anderson windows with, the low E3 coating or low E4, they don't usually hit 0.27. You can get them, but not always. To get it always, you need these factory applied coatings. Basically, they put that metallic, that low E coating is just a film of metal. It's like a fogged on metal coating. Normally it's between the panes. Now they put it on the inside surface as an extra coating.
Which must change the look from the outside.
Makes them darker a little bit, but what it really does is it means nobody can touch them with a razor blade like you painters. They scratch easily. They're metallic coating, so harsh cleaners are okay, but usually it's the painters. And once you kill them, it's a metallic coating. Once you scratch it, the window's shot, you're changing the sashes. I would recommend people staying away from those just because they're not particularly durable until they get the coating figured out. But right now, for some windows, that's the only game in town. I have people buying them and people complaining about them a lot because they ruined them before they even finished, before they moved in.
Cleaning crews can wreck them too.
Yeah, usually it's the painters because the painters will run to get that bead on the edge and then they'll go back with the blade and clean it up to make it look good. And fills the window. So you just kind of have to flag that beforehand. Exterior walls. This one is the real disaster. R30 in a cavity. R30 doesn't fit in a cavity. Also, turns out it's not actually R30. Somebody didn't know their math. R20 plus 5 is what they're looking for. Like 21 bats and then 1 inch continuous on the outside. That's what they want. I'll talk about that in a bit. Not my favorite way to do it unless unless you're really designing for that, it becomes problematic. You could do R13 if you're still hooked on 2x4 walls with 2 inches of foam on the outside, but now the problems get even, wonkier trying to attach to 2 inches of foam. R20 continuous. Ideally, this is the Joe Stiberick perfect wall. Put all the insulation on the outside like it was a commercial building, do whatever you want on the inside. You solve all the problems. There's no thermal bypass. Your moisture barrier, everything's on the outside. It solves all your problems. It just is a bitch to build that way unless everybody's building that way. Right now, we're really not set up for it here. Okay, let's talk about the walls. Can you guys see that from there? I don't know if it'll zoom in. We work in UA equivalent. You put R20 in a wall, the U equivalent, the reciprocal should be 120. But we have to take into account all the wood framing. Does that help?
Yeah.
Good. We have to take into account all the wood framing. So we do a parallel path calculation and we figure what the insulation value of the insulation is, what the framing is, plates, what the value of the sheetrock and the siding on the outside, the air film, the space that the air that kind of slows down around the surface gives you a little bit of insulating value. All of that's calculated in. When you plug your insulation into a res check, you're not getting the equivalent value of the insulation. You're getting what it would be in a certain type of wall. The required is 0.045. Let's zoom in a little bit. Problem is, you plug it into a res check, you put an R30, you don't get a 4.5, you get an 0.49. So R30 doesn't work because when the guys wrote res check, when the guys wrote the code, whoever did it decided that they thought that they should compare it to 20 plus 5, not 30. And 20 plus 5 is a 0.45, not a 0.49. So basically, R30 insulation that they're calling for doesn't work if you use a res check. Only works if you're prescriptively putting the right insulation in each hole. So they just made it even more difficult. To get to 0.45, you go to an R36. R36 is a full cavity, high density foam, filled past the edge and shaved off. Nobody's doing an R36 in a 2x6 wall. Again, at some point I'll tell you don't have to do any of this because of all the trade-offs. So, there'll be specific situations where, like, especially on a renovation, where you go, well, this wall, I can't get any of the trade-offs. I'm stuck doing this. I'm stuck putting exterior insulation.
Is that a low density or high density?
High density, full cavity, high density foam. It's like I said, you're never going to want to do this. Okay, ceilings. It's still R49, hasn't changed. But what has changed is now your ductwork must be within the thermal envelope. Can't have any ductwork in an unconditioned attic, which means if you're putting anything in the attic, you've got to spray the roof. So, again, unless all your equipment's going in the basement, you can't use fiberglass anymore. You're stuck with spray foam attics or moving all your equipment down and feeding it up.
But your exhaust vents are not part of that.
No, this is just for HVAC.
All right, just
Yeah.
double check.
Okay, so fiberglass, for the most part, is going to be out. I'm going to spend a little time talking about what, if you really want to use it, what you have to do. But If you're putting equipment in the attic, you kind of need to go to spray foam now. You know, none of this is acceptable. If you have equipment in the basement, your foundation walls need to be insulated now. HVAC equipment, if you have ductwork in the basement, the foundation walls need to be insulated. Yeah, the code changed. It used to be insulated. Now they say, once you insulate it, if there's anything in there that's not completely insulated for code, like if you don't insulate all the ductwork to R8, then the whole area is considered conditioned space, which works out well because the ductwork has to be within conditioned space. You don't have to put ducts down there. You don't have to pay taxes on it as finished space. It just is considered conditioned space.
But does that go against our max square footage? If you're
It's
considering.
not conditioned floor area. On the HERS rating, it doesn't count. You know, mechanical space doesn't count, even though it's insulated.
He's
I
talking
don't
about
know.
a town code, and that's actually gonna be a problem.
Do you consider conditioned floor area or, because this is considered conditioned volume,
Yeah,
not conditioned floor area.
the town code is really poorly written, and it was changed to fix it, but they screwed it up worse, so now it says conditioned space. It's considered square foot living area, doesn't matter as far as built.
I'll have to check the code. So I think it might just consider conditioned volume.
No,
Doesn't
well, I'm talking
consider
about
condition-
I'm talking about our town code.
Right.
Our town code says specifically that it's a
But
whole thing.
would you consider something with no AC ducts to be conditioned?
You mean if it's
If they didn't-
insulated,
If they don't have registers, but it's insulated.
but there are ducts in it?
There's ducts in it, but they're not.
If they're insulated, then you might be able to say that it's not indirectly conditioned.
Yeah, that's the
Yeah.
difference, is that indirectly conditioned.
Indirectly
Now that
conditioned,
indirectly conditioned is considered conditioned volume now.
right.
Yes,
I have a question on Zoom.
yes.
Angelo? You want to-
Hi. Yeah, hi. It's regarding the HVAC in the basement, or just say it's heating equipment, not air conditioning. Do you have to then insulate the whole basement, or can you put the mechanicals in a room that's insulated without having?
Yeah, let me back that up a little bit. It's duct work. Your boiler can be anywhere you want.
Oh, okay.
Your air handler and your duct work can.
So
When I
any
talk about
space the
mechanicals,
ductwork goes through, then that has to be insulated. Okay.
Yeah,
Thanks.
ductwork can only be in insulated space.
Thank-
When I say mechanicals, yeah, boilers, other equipment doesn't count. Hot water heaters, they could be wherever.
Okay, so just the ductwork. That's interesting.
Yes.
Thank you.
I'm losing my,
So just to be clear, we're not actually sure if that, depending on the wording, sure if that's gonna help.
Yeah, it's
Okay.
an interesting point. Yeah, we're gonna have to figure that
All right. Another change. Sunrooms and garages are now included in the code. They're kind of like a commercial garage would be. Only if they're conditioned. If you're heating your garage, there are specific requirements. Same thing with the sunroom, if you're heating or cooling. For garage, the code only says heating. So if you're only air conditioning your garage, you're okay, but generally you put in a heat pump, so you're doing both. Wall insulation R13, not 36. Ceiling insulation 19. Your glass and your doors need to meet code, including the garage door, and it has to be air sealed. We don't do a blower door. It's not part of the house. It just gets visually inspected. Specifically, the code says garage will be visually inspected, no blower door, but you still have to do it all. We have to look at it and say, yeah, you don't have giant gaping holes around the garage door. You have to have the lead stripping. Has to be an insulated door. If you're putting heat in. If you're not putting heat in, then it's just a garage.
Is there an R factor with the insulation on the garage door?
Yeah, I believe it's the same as a regular door, so it's point, I don't remember off the top of my head. Generally, any insulated door, they tend to come in around R5. R6, some of them are R12, so they all pass. But you have to get an insulated door. Sometimes it's an issue with the big commercial doors, like the heavy steel doors, but it's a house, so I wouldn't expect it to be used. But simulated performance, again, nobody uses this. It's based on energy use. They added it used to be, you took the shell, you figured out which direction the windows faced, so how much sunlight comes in. Everything else was default value, and all you were really calculating was if you got a lot of sunlight in, your house could pass, even if the shell wasn't as good. This code was designed for people who were building solar passive houses, where you had a whole lot of glass facing south, and you get a lot of sun, but you'd have a lot of glass, so the house would be inefficient on paper. I've never seen it used. It sounded like a good idea, yes.
Sorry, the last slide, the sunroom, it's not in the packet. What was the insulation on that slab?
Insulation on a slab is the same, it's meet code.
Same.
So it's, 4 feet.
So the sunroom is the same as any conditions?
Sunroom, the way they word it in the code is it says, sunrooms and garages will comply with code. And with the exceptions of R19 in the ceiling, R13 in the walls. But other than that, everything has to meet code. So your doors meet code, your glass meets code, but your insulation can be less. Thing is, if you frame, generally your garage ends up being the same as the building anyway. So it's not something that anyone's gonna go, wow, I'm only gonna put R13 in my 6-inch walls now anyway. Simulated performance, like I said, they're including mechanicals, blow door results, we're including energy use. So in theory, if you put in good equipment, you can trade that off for your shell. They give you a 15% on the TC, what used to be UA, they give you a 15% bonus towards your shell. Problem is, then they started with, if you use fossil fuels, you gotta be 20% better. If you use heat pumps, you gotta be 15% better. If you're 5,000 square feet, you take another 5% penalty. So turns out nothing passes on simulated performance. It's in the book, it's on your res check, no one will ever use it. Okay, ERI path. Is anyone working in Southampton, East Hampton, even Brookhaven? If you're working there and you're doing stretch code, this is the same thing, HERS rating. The only difference is nobody cares about the number unless you're doing ERI path. Then if you hit the number, you pass code. Even if your shell isn't good enough, if you didn't do all that crazy insulation, you still pass. If you hit the value, the ERI number, it is I think it blows up a little bit. It's a 53. If you build the house, it comes in at a 52, you get 15% extra on your shell. So your windows can go from, 0.27 to regular 0.32, 0.32, metal frames and probably get away with it. It's a big trade-off. But if you're working on something where it's a little awkward and you can't get it to pass, this is an easy trade-off. However, the trade-off, if you need to put solar on, this is the big change. If you needed to put solar on the roof to get it to pass, you can't hit a 53 anymore, and now it drops to a 40. So if you're gonna use solar, you can't put 2 panels on to get that last 2 points. You gotta use a full system to get it down to a 40. We're finding on like a normal size build, 3,000 square foot house, 4 or 5 kW tends to be enough to bring the house down past this. So basically, if your end user, if your client or whatever is planning on solar, you want to get that on and permitting, and then you build whatever you want. I tell all the architects working in the Hamptons, figure out design for solar, figure out how much solar fits, and then you can build whatever you want. Once the solar's on the roof, the house will pass. It's a good out. When all else fails, solar on the roof, everything just passes. You couldn't get the windows you wanted. When I start talking about windows, you'll see why.
So for additions, if there's already solar on the house, you can now start crediting that?
Well, this is for new construction.
Well, yeah, but the addition's gonna be considered new, but I've got solar on the house
We can
already.
only do a HERS rating, ERI on a dwelling, so it's only for new construction. So unless the whole house, like if you were doing a gut rehab, where the whole house was an addition with a gut, we can treat the whole house as new, then your addition and the whole house together meet code, instead of just the addition needing to meet the crazy code. You'll find it's not really required, there's enough outs to this. When I start going into all the little Easter eggs in the code, there's very few situations where you go, yeah, there's nothing I can do about this.
If you also want to do solar, but not on the house, you could do a ground array, which we've done in the past.
The way, again, this is up to the town.
Yeah.
Typically, if it's on the property, on the meter, it's solar.
Right.
A lot of times it'll be on the garage, outbuildings, ground array. Really often it'll be on an outbuilding.
Yep.
Just because it's more practical, because they don't want to look at it. I don't care. Generally, the utility always said if it's on the same meter, I kind of look at it as if it's on the same property, but I don't make the call here, that's.
That's fine, yeah.
Yeah.
Mr. Ricketts, we don't think.
Okay, the trade-off is you get 15% extra on your shell. So all of the whole, this installation is gonna be tough, goes away. This is where it gets crazy. This is what, like if you do commercial work, you had those efficiency credits, you could do lighting or heating or shell. Well, for residential, you got a Christmas list of things you need to do. Small buildings up to 5,000 square feet above grade conditioned floor area. Anything up to 5,000 square feet, you need 10 credits. You get 5 additional if it's over 5,000 square feet. I'll kind of go into them. If you're doing ERI compliance, you don't need any credits. However, if you're passing ERI compliance, you're probably getting the credits anyway. You know, if you're building a well-built, insulated, efficient house, you probably pass on one, you'll pass on both. Kind of things you get credits for. Remember, you need 10. You get 2 for a 16 SEER air conditioning, 4 for a 95% boiler, but that's 95% boiler or furnace. But I say before about a Whale McLean, you put in a Whale McLean Ultra, it's 94, it fails. You put in a Navi and it's 95, it's worth 4 points. So if that's where you're getting your credits from, it's really going to be critical that whoever set up the res check, whoever decided what equipment you were going to use, gets used at the end, or you get to the end of the project, you don't have enough credits, you end up failing. Dual fuel. Are you familiar with dual fuel? We say dual fuel we're talking about.
It's the oil and gas.
No, this is for a home, dual fuel tends to be something fossil fuel and electric. Heat pump with backup. And it's probably, right now, it's probably the most practical way to build. Most practical heating system is to put in the furnace you were gonna put in anyway and swap out the AC compressor for a heat pump compressor. Because you're using the same coils, right? I see the cold shirts.
Pretty much, yeah.
It's a couple of $100 more. You know, it's probably $200 a ton or something difference to go from heat pump. Is there any difference in installation?
Yeah, I would say so. It depends, it depends on I was actually gonna ask about the 16 SEER option, because I know a lot of companies like Carrier and Trinity are offering 15.2 SEER 2.
The conversion of 15.2 is the 16.
16 SEER, yeah, so I wanted to see the correlation there.
Yeah, new code, somebody at some point, specifically in the fossil fuel industry, said you can't compare my 95% furnace to a heat pump that's rated with HPSM or SEER rating for air conditioning, because that SEER rating and the furnaces doesn't include the amount of energy it takes to run the fan. And fans are big and they use a lot of electricity. So they did a new set of tests, they're calling it SEER 2 They added a 2 to everything. That includes the actual fan that blows the air around, and the efficiency went from 16 down to 15.2. Code's asking for 16 SEER, so if you see that SEER 2, there's a calculation. There's a handful of different ones. It's 95% for SEER, 85% for a heat pump, but basically it's a different test, so they're kind of similar but not the same. Geothermal's worth 15 points right off the bat. I don't think that's allowed on Shelter Island, right?
No.
Geothermal.
No.
Cross that one off.
Yep. That's all they had.
Gas instant, depending on the efficiency, either 6 or 5 points. You can see you can get to 10 pretty quickly. But you're talking about like if you put in a boiler and a storage tank, if your boiler wasn't 95, you'd get 5 points for the storage tank, but no points for the boiler. And you're only at 7, including your AC, you need 10 minimum. And you'll see in a minute, you really want 13. Heat pumps are worth 12. Dual fuel's 11, heat pumps are 12. You're gonna see a lot more heat pumps going.
Question, if you're doing the dual fuel, which is a heat pump tied into you get to 22 or 23 points for that, or is that?
No, you get one or the
One
other.
or the other?
Yeah, you either get, it's either a heat pump or a heat pump with, they take off 1 point if it's dual fuel. The catch is, if the heat pump has 70% capacity, I believe it's at 15 degrees, I'm not, off the top of my head, I don't remember. Pretty much if you're putting in a variable refrigerant flow, if you're using a high-end heat pump, the heat pump counts all by itself. The boiler becomes irrelevant. If you put in like an old school scroll compressor or P15 ream, like a bottom of the line, which would work perfectly for dual fuel because the boiler keeps up with the difference. That one, if it's not going to provide 70% of capacity at low temp, then you'd only get the 11 points. If you're putting in high-end heat pumps, you get full 12. If you're putting in low-end, and again, I really think for budget houses, a furnace with a low-end heat pump is the most efficient combination. It gives you the best of both worlds. It only costs a couple of $100. Ductless. If you look on the res check or on the paperwork, even in the code book, it says you get 7 points more for going ductless. You don't, because they added something in that says if you had to do it anyway, you can't get the credit. Wasn't in time for printing. They made it law on December 31st. They added all the addendums to the New York State law saying, oh, by the way, so it's not in your code book. Critical
Anything past the no electric, all electric, none of these apply, right?
Yeah, thing is, if they go with all electric, however, if they go with all electric, the upside is if they go all electric, then you're getting all the big points anyway, because everything's heat pumps. Only time it gets amazingly tricky is if you're building in Southampton with the stretch code, because then you need 20 or 25 points. And if it's all electric, you kind of start running out of places to get points from unless you're really putting in some crazy equipment. Okay, other stuff. Envelope. You tend to get, if you're building like a standard spray foam package, you tend to get 1 or 2 credits from this, because you're usually a couple of % better, assuming you have the windows. If your windows are at 0.27 and your shell's pretty good, you can pick up 1 or 2 points here. Again, it's usually a little bit of a crapshoot because we never know where the windows are going to come in. Windows themselves, if you put in triple pane, you get 2 points. Ducts within the thermal envelope, that's also one that went away unless otherwise required. So that one can get crossed off. But again, it's still on the res check. PV's worth 11 points by itself. There's a lot of 1 pointers. Smart thermostat. If your thermostat hooks up to the utility and they can adjust your temperature. Now, there's nothing in the code that says you have to let the utility adjust your temperature, just that you have to have the smart thermostat. Here's the one, this is what you've been waiting for. This is the credit that doesn't give you any credit. And it's buried in the credits instead of in the shell requirements. But basically it says, there we go. If you get 3 additional credits, or, see how they are highlighted. If you get 3 additional credits, so if you need 10, you get 13, or you use a heat pump, or you use solar or a heat pump water heater, your wall insulation goes from being sane R36 back to an R20, just like it was in the old code. This is massive, because you swap out that 36 for 20, and then you say, I'm gonna do a flash and bat, I'm gonna do, basic spray foam. I'm at 27, I pick up enough on the walls to cover me on everything else. So basically, if you can get the credits, you don't have to worry about the shell anymore.
Is there a specific credit for a heat pump hot water heater?
Yes, did I miss that?
No,
I might have just missed it in my, yeah, heat pump water heater is, I didn't, yeah. Gas storage, no, I don't have it on here. Oh, yes, I do. No, I don't. It's heat pump water heater, I don't have it on there. That's interesting. It's like the 12th presentation I did. I never picked up on it. Heat pump water heater, I think, is 6 points. Actually, you guys have a sheet. There's one page in there with points on it. It's got a color band, like a blue band. That lists all of the credits.
Go back to that, the credits, no, the forward, the road, you should paragraph, the New York State. No, go back, no, continue forward to where it shows zones. Next one. Next,
That one that's in front of me, yes.
the next one.
There it is.
But this is for buildings in climate zones 4 and 5, or 7.
We're 5. We're 4.
Sorry, I thought we were 7, I thought.
No, we're climate zone 4. 4 is Long Island Metro, and Westchester. 5 is upstate New York. 6 is everything north of the lakes. We're in climate zone 7 for growing. For energy code, we're in climate zone 4. We're in like 7A, I think. Something like that.
Sure.
It seems like oil is verboten in all of this.
The question was, oil, couple of problems. You can use oil. It's 85%, you don't get any credit. You could use oil, like let's say if you use oil with a heat pump, if you had an existing boiler or whatever, you could get away with oil using a heat pump with it. Use oil as your backup, oil with hot water. You get enough points. Problem you're gonna run into with oil is if you don't have sealed combustion with the new code, your oil burner has to be isolated from the living space, airtight. So your boiler room would have to be sealed off from the rest of the building and then open to the outside. Or you'd have to have an oil burner like Buderis makes one that does sealed combustion, air in, air out. Basically, you can't have a barometric damper anymore. You can't have a chimney. It has to be like a power vented system. So oil becomes tricky. The other thing with oil right now is I saw what the price was. I have natural gas, like electrification is just the silliest thing if you have natural gas. I'll get into it, if we get to the end of this, it is insane what the price of electricity is compared to natural gas right now. Propane, I was surprised, propane on the island here is the same as it is everywhere else. I was expecting that, oh, it's double because you're on the island, but it's free of change per gallon right now, which is really, it's cheaper than a heat pump. Propane is more efficient to run than anything but the absolute best heat pump you could buy. And that's at today's electric prices. Give it another week, the fuel surcharge is gonna be out. I don't know what electricity is gonna cost. Okay, so.
Can you go back to that opaque wall for a moment?
Sure. Oh, wait, sorry, wrong way.
The third thing, you had heat pump, water heater.
Heat pump, water heater, or 3 additional credits.
13.
Sorry, yeah, so 13 or, and this is kind of applied at 3 credits. If you get 3 additional credits, you could use the wall exception. And that applies to additions and renovations, and it kind of applies to everything. So I'm gonna keep coming back to that 3 credits, or solar or a heat pump. So if you go in for a heat pump, you just gotta get the 10, and you already have it because you got 11. So you're not suddenly needing 2 more. So again, if you're getting to the, there's a handful of ways. This is the whole convoluted part. There's a handful of ways to get there. We need to get the spreadsheet up. There's 2 of these, I'm not sure which one I'm gonna mix up. The res check spreadsheet. If you would, one of them, he'll know where it is. One of the thumb drives has this. Basically what we did, I'm just waiting, I have an actual one that calculates that I'm gonna bring up. What we did is, well, up until last month, we didn't even have a res check we could use. There was no, they hadn't generated it yet. PNNL Labs, the code went in. They didn't know what the code was because New York State didn't actually put out a code book until October. So no one thought to put together software. We just got software middle of February. And I kind of did all of the, I kind of did all the possible calculations. So I can kind of run through and you can kind of see what works and how you, it just will give you a better idea of what we're trying to talk about when we say, value engineering this down. Just give me a second, she's putting it up. Any questions while I'm waiting? Yeah.
It seems like we should be targeting architects primarily. In order to get a permit to build a house,
Yes.
registered architects have to submit the plans to the town with all this on there.
I did 2 of these classes for AIA Long Island, Nassau County, and 4 of them for Peconic. Problem
Maybe
was,
this class will make us understand why things cost more money. But as long as we do what's on the plans, we shouldn't have a problem as long as they've been approved.
yes, the thing is, I was a builder before I did this. I never looked at the plans. You really look at you look at the layout, you figure out what windows you're buying.
Looks pretty.
Once you start snapping out walls,
Don't give him
I mean, honestly, once you started snapping out walls, did you go back to the plan and go, where did the studs go? Or where does the sheathing go? Like, the things that are on the plans that you ignored, like the boiler they picked. And, the air conditioning, that wasn't on the board. If it was on the plan, it was a boilerplate page that had been there for 30 years.
Like, my HVAC guy will not even give me a price until he sees the res check.
Right, but
It doesn't make sense.
now, that stuff that's on the plan was the way they got the shell to pass.
Right.
So now your boiler is no longer, oh, what would you like to put in? It's, if you don't put this in, you don't get to pass your shell and you need continuous insulation. So, that's kind of where things, like day one to the end, it has to be continuous. You can't just say, I got the plans, I'm just gonna build it. I built the code, who cares? Now it's, I gotta build the way we originally modeled or figure out a new combination that works.
Well, that's why they call it a plan.
I think in the 40 years.
Well, except,
I think in the 40 years that I've been building, I've never seen the HVAC plan.
Yeah. Now, however, in the 4 years, you would have seen manual J and S.
Yeah, definitely.
Well, manual S is gonna spec equipment. Now, the equipment they spec, and again, I do the manual S's, I write or equal, and my disclaimer says, and the HVAC guy can pretty much do whatever he wants within reason, but, because they're not gonna use the equipment I picked, they use whatever brand they use. But that SEER rating is now absolutely critical. You miss that, you fail. For the HERS rated homes, that was always an issue. Oh, you You're supposed to put in a 95, you're supposed to put in a gas-fired Navian wall-hung water heater, and you put in an electric tank. And it costs you 15 points on your rating, and you can't put enough solar on your roof to make. I've had people take out their water heaters because they put in the wrong one. The only option is to tear it out and put in another one.
Exhibit A, right?
Didn't work for me.
Give him right.
Okay. This is gonna be a little problematic, because I kind of need the keyboard. So I'm just gonna have to, watch that instead of watching me, because I can't manipulate this without a keyboard. Normally I work off a laptop. Okay, so this is, let's see if this can stay on. This is a standard two-code design. This is, R20 plus 1 inch, R49s in the ceiling, 30 in the floor, 27 windows, 19. This is if you just built to code. And you can see down at the bottom, you end up being 3 UA better. You're required to hit a 282, you hit a 279. So I'm just gonna kind of go through what's in my head when I do one of these. First off, R49 ceilings. That assumes what they call a flat ceiling. You put insulation in the ceiling, when it gets to the edges where the eaves are, it's compressed. So ResNet gives you, ResCheck gives you a penalty because it's compressed around the edges. It turns out if you put it in the ceiling, oh, this is the wrong version. The wrong, it's the wrong version of this. It's on the other thumb drive. Spreadsheet presentation. No.
Somebody has to go check. They just double check they are equal
So you have the hearth rate picking on the cats. You're getting the
Okay, change of plans. We're gonna break for lunch, because it's already sitting here. They'll give me 2 minutes to get this figured out.
somewhere. Weird, okay, right. So like I had like 5 to 6 like 50,000.
You ready for math? Can everyone see this screen? Unfortunately, we couldn't do it on those just because it was, I didn't have the right setup on that machine, only on this one. I don't have a mouse here, so it might be a little bit thumbs, so bear with me. Okay, so this is kind of the thinking process when I value engineer. I just want to kind of go through and you'll see what we start with and what we end with, two completely different things. So right now, we're looking at a basic code design. First thing you can come up with here I'm going to go from an R49 in the ceiling to an R40. Whoop. Sorry, again, I don't have a mouse, so you'll have to. Pretty standard 3-inch flash and bat. 3 inches of high density is 21, R19 bats gives me a 40. If you notice, I'm still at 0.26. If you put the insulation in the rafters, they consider it, there's no sealed attic in ResCheck. They assume it's a cathedral, and they assume that entire rafter will be filled with insulation from top to bottom. If you put it in a flat ceiling, they assume you're going to crush it at both ends because of where the roof rafters pick up. The eaves end up being compressed. So they already gave you a penalty. If you put it in the rafters, they treat it like a raised heel truss, full height all the way around. So what we thought was R49 is actually only R40. So if you spray in the attic, code is a 40 in the rafters. 49 if it's in the ceiling, only 40 if it's in the rafters. Doesn't say that anywhere, but that's what the math works out to. Now, I am still just barely passing. However, I'm going to take advantage of that energy credit. We've got those 3 extra credits or whatever it is. So now my walls go from R36 or 20 plus 5 to a plain R20. I'm going to add in that energy credit. Now, if you notice on the UA, I'm now 33 better than code. If you think about it a little bit, when you look at these values, the required for walls, 124. The required for the attic is only 29. Because it's more insulated, it loses a lot less energy. So if you add more insulation, it's only 10% or 15% of the overall. How much difference do you make? The things that use the most energy are the ones that make the biggest difference. You put in a window that's, from 0.27 to 0.28, it's a drastic change. You change your roof insulation from a 49 to a 60, it doesn't even move the needle. It's the things that are really well insulated have a really low UA. We're adding them all up. So if I save 5% or 10% of the walls, I save 12 and a half. If I save 10% of the attic, I only save 3. So it's a lot about where the insulation's going. The worst insulated things, if you make them better, you pick up a lot of credit. So just by going for the energy credit, I'm now 33 over. I could dial that down pretty quickly and put in a regular R21 bat. Again, I don't have a mouse, so it's a little clunky. I'm still picking up 6 just by putting R21 bats. Now you're going to spray the roof anyway, so if you go for a flash and bat in the walls, standard 2-inch flash and bat, now I'm at R27, I picked up 18, 19. Now if you notice, my roof rafters altogether are only 29, and I'm 18 ahead just from the walls. So I can almost take my roof, I can drop my roof insulation easily down to 30. I'm going to do that right now. So I lost 9 on the roof, but I'm still 10 better than code. So it's really about where you pick it from.
So now this is now a standard flash and bat. If I was speccing for any house and they said foam, I'd put 2-inch flash and bat and the walls are 27, put R30 in the roof, and the house is passing with flying colors. I could even make up a little bit. Now, if you notice the windows, where I said the walls required was 124, the windows required is 108 compared to the attic, which is only 30. It's all about the glass. And this is a house with just a normal amount of glass. If I can't get 0.27 windows, it's going to a 0.28, I lose 4. Go to like a standard Anderson low E2 window that you'd buy at Home Depot, a 0.30. I'm just barely passing, just barely failing. So you can get away with normal windows. That 0.27 goes away. If your walls are a little better than code, your windows could be normal. You're not struggling to hit 0.27. This design that I'm using is a 2,000 square foot, 2-story colonial, if you want to, center hall colonial. It's a box, 2 stories tall, 2,000 square feet, 1,000 per floor. If you're building something near the water, or you're building something contemporary, your windows might get a little crazy. So instead of the 20% windows, I'm going to go to double that. Now I'm starting to take a big hit. This is where ERI compliance becomes a real lifesaver. I'm going to put this in as down here on the bottom. I have a little option for with ERI. This is going to give me that 15%. Now I'm passing by 50. Now I want to use metal frame windows. I want to use Fleetwoods. I'm building a monster and I want to put Fleetwoods in, which I see a lot because they're half the price of the $12 million windows. So they're only $6 million. I'm going to go with, say, a 0.38. Oh, not quite. I was guessing. It's been a while since I did this presentation with these numbers. How about a 0.37? One more time, 0.36 for good luck. There it is. 0.36 window, which is pretty much any metal frame, like a Fleetwood aluminum, broken aluminum frame. You could pretty much use any window you want, a basic spray foam job, and still meet code if you hit ERI. Now, if you put in those windows, you're not hitting ERI on shell, you're going to be hitting it with solar. So basically, if you don't want to spend the money on glass, put some solar on the roof, and you still pass. So this is kind of my calculation. The key to this is no matter what happens, I absolutely need that energy credit. So I always want that 3 points or that heat pump. It's almost a mandatory. Otherwise, I have to do everything over the top to pass. So it's kind of, you start with the energy credit and then you build a normal house. You want to get crazy on glass. You want to put in a lot of, like I said, metal frame windows. At that point, you need to go with the ERI compliance. Also, just to keep in mind, when you're talking about glass for res check, if you're at 0.27, it doesn't matter how much glass you use. If your glass comes in at 0.27, that ratio of glass doesn't hurt you. People are like, oh, I got so much glass, it's going to fail miserably. Makes no difference whatsoever. Because if you look at the math there, we just compare what was proposed to what was required. And they just calculate how many feet of glass times the U factor, and that's the proposed. And then whatever you have is the required. It doesn't change for either. It does change for a HERS rating. You have a lot of glass on a HERS rating for ERI compliance, you start taking a penalty after 18%. It starts treating the window like a wall because the maximum you're allowed to have on your wall is 18%. So you start getting penalized over that. So what ends up happening is on a real monster house where you have a lot of glass, you might need more solar to make up for more glass, even though on code you don't. So it gets a little tricky. All right, does this make sense? Everybody kind of got that? This is the key to dealing with the new code. Work that credit, take as much advantage of it as you can. If that doesn't work, go to ERI compliance. If you're the builder and you're halfway through construction, and suddenly you're ready to get your windows and they realize they don't want to buy Riley's and basically trade half of Long Island for a set of windows. At that point, they want to downgrade the windows. You get a trade-off $20,000 or $30,000 worth of solar for, I've had one project for $750,000 worth of glass. They just added another $35,000 worth of solar to cover it. They were able to use any glass they wanted, just really because they put enough solar on to make up the difference. It's all a trade-off within reason. You've got 15% plus that wall credit, which gives you about another 10%, 15%. There's a lot to go there. At the end of the day, your building is still just as efficient as somebody who built it using these values, because we did the math, we did the calculation, it gives you efficiency. And it doesn't matter how you got there, just that you got there. All right, can we switch back to the presentation? Did you kill that? No, I'm just going to kill this screen for now.
So is New York State still limiting how many solar you can do? Like, is it still like a limit, like 15 kW?
New York State doesn't limit it.
Or PSEG?
PSEG limits it to 25 kW AC, which depending on, if you have perfect south solar, it's about 27, 28K. If you have east-west or a combination, it might be 32 kW. It's a massive system. And also keep in mind the rebates go. Right now, you're limited to $5,000 rebate from New York State. Federal rebate's gone. However, New York State code doesn't care how you get your solar. You can lease it. You don't have to own it. You just have to have it on the roof. So you can use one of those solar leases. You don't really make as much money on them. I don't know if you make any money on them. I think the solar guys mostly make money, but you pass. So it is an option. All right, takeaways. Target value for roof is 40, not 49. I have never spec'd 49 on a res check or on a HERS rating. Sometimes the architects, if the architects are building hyper insulated and triple pane windows, they'll spec it that way. A lot of times I just see it on there, they put 21 on the walls, 49 on the roof, because that's what it says in the code book, if you don't do all the math yourself. As a general rule, and I guess something to read about, but if it meets res check, you should be able to value engineer it even after it's drawn. I know on a HERS rating, if it passes at the beginning, it passes at the end, that's generally good enough. I don't know how the building department feels about the plans not matching. You'd probably need a revised set and a new res check, or in this case, a new HERS rating. We do that all the time. On a regular basis, I get a call, what if we do this? I would change the model. What if we do this? They change the model. The bigger projects, that sometimes happens 8 or 10 times before they decide what they're buying, because they want to value engineer everything, they want to pick specific things. So that's like the upside, is as long as you meet code, you meet code. It's just a matter of you have to show the revised paperwork. I'm doing that anyway. I'm generating paperwork at the end. You get that. So that's, you see R49, I would always hold R49 in an attic suspect. When I see that, my first thought is, whoever put it in there just put it in there because it said 49 in the book. Unless they have 40 in the walls and they're this thick, they probably didn't mean to put 49 in the attic. It's just not necessary, it's just easy. When we do the math, we value engineer that. It doesn't save any energy to go with 49 in the attic. The difference between 40 and 49 on that 2,000 square foot build is probably about $8 to $10 a year. It's all that makes a difference. It's so well insulated, the heat loss is so low that putting more insulation doesn't make much difference.
if the whole ceiling only cost you $200 a year for heat loss, making it 10% better is $20, not $100.
You're talking about a home energy model, right?
Yes.
You have modeling software.
Yes.
If we're using like a product like Revit and we're modeling the entire house, is there some type of plugin that would allow us to kind of monitor where our energy installation values would be
There is, specifically there is for AutoCAD.
for Revit?
I'm guessing Revit's owned by AutoCAD.
Yes.
So it's probably, I don't know, I'm not that familiar with Revit.
What software do you use for?
We use RemRate, which is strict, I use RemRate and Ecotrope are the two models. They are specifically modeling software, they're not design software.
Right,
All we do is plug in the numbers and spits out.
but it would make sense. I mean, the whole model is basically built, right?
Right, I mean, if I could give you a copy of that spreadsheet,
Yeah,
you're welcome to it. I don't normally, because it's basically res check.
Right.
The only thing nice about this is you don't have to keep running it each time.
right.
And it doesn't give you an error until it passes. This just tells you where you're at. That's why we did that. We mostly did it because we didn't have a res check, but it turned out to be really useful for playing around. So what if I did this? What if I did that? Okay, takeaways. 40 in the graph is not 48. 49, let's see if I get this back. I lost it again. Okay, there it goes. If you get the 3 credits, or use a heat pump or solar, you get the wall credit. You absolutely need to get the wall credit. Nobody's gonna be building, unless you're planning on using, if you're doing insulation board on the exterior, if you're already thinking that way, then it doesn't matter. But I rarely see houses that are insulated with exterior insulation. That's kind of like the fiberglass jobs. And I have some issues with those that I'll get into. Window to floor ratio is critical. Assuming your windows are worse than code, having a lot of glass is a problem. If your windows are better than code, if you put in triple pane windows, the more glass you have, the less insulation you need to pass. I have a couple of houses where they're putting in a lot of 0.20, 0.18 triple pane windows. You can get the wall insulation down to 6, the attic insulation down to like 19 in the house still has. It's just, I did it as an exercise to see what it would do. All right, a little bit about assemblies. This is more for the builders, the other stuff is more for the architects. Continuous insulation, this is what they want us to go to. This is like the drive right now. We're not there yet, mostly because the details, the flashing details and stuff aren't really hammered out. And if you work at a place like Shelter Island where you have to deal with wind, now you have to have all your siding attachments meet hurricane code. Adding an inch into a foam on the exterior becomes problematic. I did a project in Nassau County that we got a grip. I used to run the Habitat for Humanity in Nassau County. And we built a little tiny house inland, but the insurance company, Travelers Insurance, gave us money to fortify it for hurricane proofing. Hurricane, flood, we got a good sized grant, kind of, it was like a test house for that. And I had 3 inches of foam on the exterior walls, 4 inches on the roof, and then we sheathed over the roof to put shingles on, and we lapped the walls to put vinyl on. Well, for hurricane, all of the attachments had to go through and hit framing. So I was buying 8-inch and 8 and 9-inch structural screws at $1 and change a piece that had to be drilled through 6 inches of material and hit 1.5 inch stud. So we had these drill rigs to try to hit it. We had spotters on the inside and cell phones to let us know when we missed. We had guys with foam guns with little tubes to refill the holes, to reseal them. I could see this being like a labor-intensive nightmare until somebody figures out a system. The only system I've seen that really looked good is they kind of look like the legs you use on drop ceilings. It's like a threaded leg. You screw that in first, you push your foam over it, and then you pop that over your plywood. You whack the plywood to make all of the marks, drill those out, put them on and bolt them in. I just, labor-wise, it's gotta be insane. But again, that's kind of where we're going with this.
What about putting the sheathing on the outside of the foam?
Then you have to worry about shear. Actually, I'm gonna get to that in a second, so I will talk about that right now. Siding attachment has mostly been the issue, especially when if people are building shingle. You're putting wood on the outside, this gets rough. If you're doing board and batten, you can make it work. You're gonna do a rain screen anyway, you can make it work, put, purlins or girts, whatever you wanna call them in, and mount your siding to that. But it ends up being something that needs to be engineered, not just something that can be done on the fly on site. Biggest issue is getting it watertight, because now your window details become 3D. Now you have to match, your siding is gonna be out a couple of inches, so your windows really need to be out a couple of inches. So now instead of taping your window flange right to the water barrier, you need to wrap it 3D. I see these painted ones. The only problem I've seen with those is guys used SPF to pad out the windows, and it dried out. By the time the siding was done, that had cracked because all the wood had pulled away. And they ended up with leaks around every window, and ended up tearing off all the siding to fix it. So it's not that this is an impossible thing to do, it just definitely takes more thinking than the standard way we build. Door jambs are another one that nobody thinks about. If your doors swing in, your extensions, your jam width is set. Your windows, you slide them in or out for more extension jam. Door has to be flush on the inside to swing in, which means the door frame itself, the jam has to fit the size wall you're putting in. And if you start getting odd sizes because you put foam or you put lath and you're siding, suddenly you start having to have custom doors made. Other option, this was the question with the sheathing on the inside, something like zip wall. There's actually a lot of companies that make the equivalent of zip wall without the waterproof barrier. It's just sheathing with foam attached, and then you put your own Tyvek or whatever. I'm not personally a big fan of zip wall, mostly because I don't trust tape yet. I've worked on houses upstate that were from the 1700s, and they were still basically watertight because they had asphalt shingles on the outside.
There's 50-year tar paper still.
Yeah, even 100, like my house is from 46, the tar paper was still solid from 46. I don't know that I'm gonna see any tape 100 years from now. And I don't know if I'm gonna see any foam 100 years from now that hasn't turned to dust. So I worry about maybe, if you think about it, in 100 years, what's gonna be left of any house?
Looks like rock to the ground to begin with.
Well, but what's the typical, you restore houses, there's plenty of houses here that are from, early 1900s, what's left? Probably the siding's been changed, the interior's been gutted, the plumbing, the electric, the stick framing, and the foundation. When you start messing with those two, then it's, if I put foam between, if I'm relying on foam to keep my sheathing on, then when my foam goes bad, my entire exterior has to be redone.
Some of these houses work on in Heights that the sheathing is tongue grooved on there since 1870s, and it's an inch and a quarter, inch and an eighth.
My house was
In their building frame.
1946, it was tongue and groove, 3/4 inch tongue and groove, pine, not fir, it was actually pine. And whoever had redone the house before I moved in had changed all the windows, took out the double hungs and put in double casements, and didn't bother putting headers in. So I opened up the walls and there were no headers anywhere. Like the headers just started and ended short. And the only thing holding the second floor up was that 3/4 inch tongue and groove. And amazingly it did, because I didn't die.
I saw something recently where it's a double wall system. So you have
Yes.
your exterior framing, and then you have an interior staggered wall on the interior, which allows you to do continuous insulation on the outside, and then all of your electrical and plumbing and ducting is in the interior wall. Is that,
There are a handful
all this is
of-
adding cost, but does that work? in terms of this?
Absolutely. It's just, there were a handful of them, I've done a few on Shelter Island. It's definitely it's a thing.
It's a passive house detail.
Yeah, passive house.
So you know, it helps you with your penetration.
Because everything you also can do is you can put continuous insulation between the two layers.
Yes, that's the whole point. Then it gets around that
Yeah,
requirement, right?
at that point though, if you have a double wall, you're talking about, R40 or 50 insulation, you're so far beyond code. From a cost standpoint, putting R50 in a wall isn't gonna save you enough money on energy to ever, this is for bragging rights. You build.
It's not that, my question is, what you figure, so talking about on your breakdown was R20 plus 1 inch continuous, which goes to the out, which they want this continuous sheathing, insulation on the outside.
Absolutely, but again, if you're at that point, you're so far past, that you could frame a 2x8 or 2x10 do the same thing.
Okay.
We're getting into the so much better than code that all of this is irrelevant. You don't need, if you're putting the continuous in the middle, that's even better, but now you're paying for 2 walls and you're losing a foot
No,
space.
I get that, but all this
Yeah.
is driving.
I mean, absolutely, when you start talking about, what if I did this, like SIP construction or any of those, if you're building like that, then you don't care about any of this. Code becomes irrelevant, which is so much better than it already. Then you're looking at structural, not energy code.
So if you were just to
Interested in
sheet,
that, look up Saskatchewan Spring.
I'm sorry?
Built one 40 years ago.
Yeah, no,
if you were just do typical sheeting, right, and then maybe you did a drainage mat outboard, and then you did this because you're concerned about the dew points capturing between. Would that solve that would basically solve your structural issues?
Doubling the,
Just do typical sheeting like it's typical,
and then go over the same.
and then just go over it with this,
And then put a layer
and you
sheet.
just put a layer, but you would have to, I guess, figure out where your dew point is, so you don't trap moisture in
I'm
between
gonna
the sheeting.
hit that in another slide.
Oh, perfect.
Okay, insulated sheathing. Couple of issues with insulated sheathing. They don't really talk about it yet, because it's one of those things where everybody thought in terms of insulated sheathing, everybody thinks in terms of really cold places. Nobody thinks in terms of mixed climate. So we have a summer and a winter. So we have to worry about, like, people putting plastic on the inside, you get mold on the inside. Plastic on the outside, you get mold on the outside. Dew point becomes an issue, and in this case, shear becomes an issue. If you put the foam first and then the sheathing, normally when you frame, anybody doing lead-in shear bracing when they frame, you just put sheathing on and it becomes your shear box. Well, if you don't have sheathing connected to the framing, you don't have any shear strength. They give you the shear values for this. They say your maximum width to height, it has to be 4 feet wide for 8 feet tall for shear. They give you the shear rating, but that's basically for a 1-story house. And you need that at every corner to meet your shear requirements. Again, I'm not an engineer, so I don't know the math on these exactly, but basically, if you're putting up insulated zip wall instead of sheathing, you need an engineer to do the math, but there's a good chance your building's gonna fall over.
We've heard of that happening, and our engineer has actually specifically told us, don't ever spec this because you can't get those 3-inch screws to engage enough.
Yeah, and even then, you get wiggled because there's some play. Now, there are people, if you go down south, they don't use sheathing, they use styrofoam. They use tough R. Tough R is sheathing, not insulation. You have foil on the outside, so it's sheathing. They used to use Homosuke, but we used to use lead-in braces. So your building would be framed solid and rigid against shear without the sheathing. We kind of got lazy, we put the sheathing on, that solved the problem. So as we went from tongue and groove to sheathing, we didn't have a shear issue anymore. You start going to foam instead of sheathing, you're back to having that shear issue. They make plenty of assorted shear panels that you could just bolt in. I see them a lot now, especially when houses with a lot of glass where they don't have enough surface area for shear walls. For a builder, these are a real expensive pain in the ass, because you gotta nail it where your bolts go. They have to be in exactly the right place. You can't, there's no, it's not, okay, it'll be fine, I'm gonna hit the corners. You gotta have these bolted in all the right places, and any place you have one of these, you can't have fixed light fixtures, you can't have boxes anymore. They work, but they're not an easy way to do it. And if you're doing foam, you're kind of stuck with this. So, the problem with the insulated zip wall is if you don't have shear someplace else, you're gonna have to add it in and adding it in gets expensive. Other issue is condensation. This is kind of where I earn my keep. Interstitial condensation, I run into it on a regular basis. You get into, you start looking at it going, that's not gonna fly. It turns out, if you're in New York State in climate zone 4, New York code doesn't fly. You're likely to have condensation problems if you follow 20+5. It's for climate zone 4, but it's not for Long Island climate zone 4. Climate zone 4 goes all the way south. We're at the coldest, we're almost climate zone 5. Take the ferry, you're in climate zone 5. But we're getting treated like 4, even though we're in a reasonably humid winter, and it's as cold for as long as it is across the other side of, go to Connecticut, you get the same weather we are. They're at 5, we're at 4. What we do down here would never fly up there because it would be a condensation problem. So this was like, everybody remember the 70s in vinyl wallpaper, you open up this mold underneath, summer problems, because the humidity would come in, hit the coldest point, which would be the sheetrock or the vinyl, house was 70 degrees, you're below the dew point, you get liquid. We run into the same issue outside. This is a typical old school framed wall fiberglass insulation. Inside 70 degrees, 35, 40% humidity, assuming we built it nice and tight, it's hot and humid, the way we want it inside in the winter. Outside, we got 30 degrees. Our condensing surface is going to be the plywood, because that's going to be the first cold surface that vapor hits. Water vapor hits it, based on 30 degrees in, 70 degrees out, dew point to that wall is 41 degrees. All the insulation's on the warm side, so that sheathing is pretty much going to be whatever it is outside. If it's 30 degrees outside, it's going to be 30-something degrees on the sheathing. Not that much heat getting to it. I'm going to have moisture. The way we used to build is you put vapor barrier on the inside, would slow the moisture. It would soak into the plywood, and it would eventually dry out because it's really dry outside. Wood's pretty permeable like a sponge. As long as we didn't let it get in faster than it gets out, it would just keep drying. And again, like we're in climate zone 4, you don't even need a vapor barrier. You don't need crap paper. You can put in bare insulation. Passes code. But if you do that, you're going to be letting it in way faster than you let it out, and your plywood's going to rot. It's going to soak up with water, and eventually it's going to freeze and decompose. Now I put insulation board on the outside. I put that R5. The surface of that foam is now plastic. It doesn't let moisture through, and that's my condensing surface. So where before I would soak it into the wood and let it out, now it soaks into the wood, the plywood up against it, but it can't go out. It can only come back in, and inside is warm and humid all winter. So it's not going anywhere. So it just keeps building up. Dew point, still 41 degrees inside temperature, but now I have to calculate what's the surface of that foam, what's the inside surface of that condensing surface going to be. Turns out it's pretty involved. Here's the formula for it. Basically, temperature in, temperature out, insulation in, insulation out, rigid to total. I kind of know the math, but it makes my brain hurt. I hire people he's got a physics degree, so he's my guy for redoing these spreadsheets. So I get my young brainiacs to build these spreadsheets for me. So I actually have these, I have all these ones I'm popping up. If you email me, I'll send it to you if you want these. I didn't do thumb drives. This was kind of, I wasn't sure who was here, and last minute, I didn't have time to put them all together. But I'd be more than happy to send you copies of these. Dew point calculator. You put in the inside surface, the inside temperature, outside temperature. We assume that outside is the average temperature of the coldest 3 months of the year. Long Island is typically 30 degrees. We assume 30 degrees outside, and then you put in what insulation value in and out, and it'll tell you good or bad, green or red. It gives you the dew point of the surface and what the surface of the foam would be. Anytime that foam temperature is colder than the dew point, you're putting water in. The lower it is, the more time you have putting water into the walls. So if it's a lot lower, you might have 20% of the winter, you're wetting that plywood. If it's a half a degree, it might only be 2 or 3%, you're probably okay. Well, do the math. They assume 4 to 1. Rule of thumb is if you have 1/4 of your insulation on the outside, or you're on the other side of your condensing surface, you're okay. Typically 4 to 1. That's the climate zone 4, 20%. For us, it doesn't work because we're in almost too cold for that zone. And again, I'm figuring 35% humidity. Plug those numbers in. My foam temperature is 37 point something. My dew point temperature is 41. I'm going to be putting water inside my walls for whatever percentage of the winter. If I go with 40% relative humidity, which now I start spray foaming. I'm going to put foam in the attic. I'm going to have foam on the exterior. There's no real place for the moisture in the building to go. I made my building perfectly airtight. It's like being in a tent. You sleep in a tent, you wake up, there's like water dripping off the stuff. That's how sealed the house gets. So ideally, I would love it to be 40% inside my house in the winter. That's like, in the winter, summer you want it at 50%. In the summer, in the winter, 40% would be wonderful. Anything higher than 40%, my windows would start dripping. I start having, I hit dew point on the glass, but 40% would be really nice. Except that dew point inside my walls, I'm going to be using my walls as a dehumidifier all winter long, and the water will be draining out the bottom. And that's if I build it in code. So you really have to watch that 20 and 5. It doesn't work. Sounds like it should, but it doesn't work. It's in the code like it does. But again, they weren't assuming northern climate zone 4, they were assuming average climate zone 4. All right, for the zip wall, they give you a perm rating of less than 1. And I talked to the reps and I said, well, how much less than 1? Oh, you have to talk to the engineers about that.
So what do you recommend?
Well, I don't recommend 1-inch foam and R19 or R21 bats. Personally, I like spray foam on the inside. If you're going to use foam on the outside, I'd like to see 2 inches of foam. The other thing is, if you're going to go to all the trouble to frame out for continuous insulation, if you're going to go to all that trouble to frame all your windows out and buy door frames, why not do 2 or 3 inches on the outside and actually insulate the hell out of it? And put 1 inch, or sometimes you see the guys putting half an inch of foam. They put the foil face fan fold board. All they're doing is making sure none of the moisture ever gets out and that they trap it in the sheathing so it'll rot. Like that vinyl siding with fan fold is a disaster. You have to use the porous one, like the blue one, not the foil face one. They actually sell one with perforations, little holes pinned into it to let moisture out, but no one uses it because it costs more.
The 2-inch gives you, it's worse on just the racking of the, you're building more simple rack.
Well, again, you'd still have to, if you're putting 1 inch or 2 inch, you'd still have to deal with shear. Even if you have 1 inch, unless you're building a little tiny cottage with almost no glass, you're not going to be able to put 1 inch.
That's why I was asking if you put a layer of, if you put sheathing in first and a drainage mat.
Well, you just put,
and then you put your insulation on top of that.
And then just put girts or purlin, something
Right.
to nail.
So you can do your interior, you can do interior bat and then or spraying bat, then you do exterior one, but you do a drainage mat in between there.
Sure.
So you basically bind sheathing.
Wouldn't the drainage mat screw up your insulation
Well, but
valve?
the drainage mat is really just acting for
Behind it,
air.
no, that's an acceptable way to do it.
Yeah.
The downside to that
If you're
is,
layering it up, and it's more labor.
the downside to that is then you have to waterproof all your windows to the back sheathing.
Right.
If you put another layer of plywood, then you move your windows out and you deal with everything flat. So generally, the way to go would be to use like a zip wall style and sandwich it.
But then again, your attachment it is absolutely doable. It just costs money because labor is expensive and you need a lot of it to do those.
Well, even with the windows now, they want you to put the thermal break in line with the installation so you don't get the bridge,
Yes.
which is try to get that back.
Yeah.
So what I was gonna say is, on your wall there that you had before, and you have the insulation on the outside, and you're saying that that's gonna be a vapor barrier essentially.
Yeah.
But you were talking about the moisture coming in on the inside of that. Well, now if you have Tyvek or some semi-permeable membrane there, isn't that gonna take care of the transformation of the
The foam,
waterproofing and,
well, you have Tyvek, which is permeable, but you've got foam behind it that isn't.
no, I mean the other way around. You put the foam on the outside, put the Tyvek on the plywood.
It's good, the moisture is gonna go through the Tyvek because it's vapor.
Right, because that's the way it's supposed to go.
Right, but it's basically gonna stop at the Tyvek in the plywood, because it can't get, plywood is gonna be the condensing surface.
No matter what.
Well, that's, because that's gonna be the first hard, cold surface it hits.
You need 2 inches on the outside.
Outside,
for the
right. If you do a
plywood to
flash and
have the,
back, if you do like a
condensing
flash and
surface.
back inside the wall, you can do 1.5 inches of foam, R10 or so, and then an R13 back. You're almost at 50-50, you'll never have condensation. If you're gonna put it on the outside, now you're upping the inside insulation to 21, or 19 even. That part, you need 20 for code, so let's say 21. The 5 on the outside, your ratio is so close to that 4-to-1 that it doesn't work as far up north as we are. So, if you used 1.25 inch insulation or 1.5 inch insulation outside, you'd be okay. But like I said, if you're gonna do 1.5 inch insulation on the outside, you might as well just go all out and put 2 or 3 inches on the outside. You're gonna do all that work of padding it out to do the efficient way to build it, you're better off just doing it all right. Or move it all back to the inside and do it the way you always did. Which honestly, I kind of recommend because we're not saving enough energy. I'd much rather see you save all that money and all that labor and put solar on the roof and actually generate some energy than save nickel and dimes on the side.
Sure.
Keep walking away, I'm losing my clicker. All right, how you get around that? Easiest way is don't put foam. If you use vapor permeable insulation on the outside, that's Roxel board, Roxel Comfort Back. Problem solved. It's actually really nice to work with, it just costs a lot. Again, we're back to who's spending money. I'm gonna kind of just talk about what we see and why. The whole idea of exterior insulation, great if you want to do it. I'm assuming you're gonna get that wall credit, those 3 points, and you're gonna get that opaque wall credits. So you're not gonna need to deal with the 20+5. Let's just go with that assumption. In which case, what would I do in a wall? If I'm on a budget, fiberglass will work on the walls. R21 bats, slightly better than required, you needed a 20, you'll pick up a little bit on the UA. The walls are basically airtight because there's sheathing on the outside. You put sheathing in Tyvek with sheathing and blue skin or something. I don't get leakage from the walls. All that leakage that comes in around the electrical outlets and everything, it's not coming from the walls, it's coming from the attic. I'll talk about that in a minute. Cheapest option. You don't pick up that much in UA, but it works. If you wanted to cut costs and put fiberglass someplace, walls is the place to put it. You can go to full cavity foam. I like this the least. Low density full cavity foam gives you the same R value as fiberglass, R21 full cavity. But all your wiring is buried. You can never put anything in there. You can't cut a hole and drop a wire. You can't snake something. You're totally encapsulated in foam. I think there's no benefit to it other than the insulator might charge you a couple bucks less because he doesn't have to bring a separate crew and he's got the foam gun anyway. So I'm seeing a lot more of it because the insulators are saying, oh, I'll do foam for the same price. Personally, I just think it's a waste of time and money. I don't really like it. Again, it's got its pros. It's nice and quiet. Makes the building a little more solid. it's a nightmare for the trades.
Oh, wait, wait, seeing that, and I'm like thinking, well, if you use the high-density foam, you don't have to worry about the shear, because it ain't going anywhere.
Well, if it was rated, it absolutely doesn't. I've seen, we had a couple of historic projects in East Hampton that were, you were standing in them doing this when the wind blew. You know, once they pulled off the lath and the plaster, the whole place was wobbly. You foamed it, it was like being in a refrigerator. It was just dead quiet. You didn't hear anything on the outside, it didn't move. Does an amazing job for it, but it's not rated for shear, so.
And
He's not gonna like it.
eventually, when it turns into dust, then it's.
Yeah, then you have a
Well,
wobbly
that's
wobbly
time
house
for it
that's
to fall
not
down.
insulated.
I need a new one.
Okay, my personal choice, flash and back. 1.5 to 2 inches of foam, R13 bats. If money's no option, use R13 Roxel. You'll have the quietest house anyone's ever seen. It's amazingly quiet, add those two together. Couple of pros to this. It's an R27 with a 13 bat. So it's an R29 with a 15 bat. So you can really pick up on, for windows or something else, on that three-way trade-off. If you're spray foaming the roof and you're flashing the walls, you can start insulating, you can start drying the inside of your building before any of your trades show up. So you spray the whole thing, just spray 2 inches on the walls, spray the roof, wait on the bats, let the electricians come in. Basically, you're left with 2x4 cavities. So the electricians and the plumbers, everybody works like normal, but you can have temporary heat. You can dry the whole building out. You can get your floors to acclimate. You can do all of that long before you have drywall. It really smooths it. It's really nice when you walk into a construction site. There's people everywhere. Everybody's working. You walk into a place that's 60 degrees, and they've got one little heater going. You know, usually they take like a 3-ton or a 5-ton or a little furnace or something, and they just pipe it in the window. I've got a lot of crews that are air conditioning in the summer. I'm guessing you guys do a lot of that.
Oh, yeah.
Just throw in temp heat and temp cooling.
Yeah,
If
it's a
you
little,
dehumidify in the summer, you can get all your flooring ready to go, all you would at humidity and temperature 2 months before you're ready for it. And you don't have to find someplace to store it, pick. It's a really nice way to build. Cons, cost more. However, since a lot of the guys are showing up with a gun anyway, it doesn't cost that much more. I have a couple of insulators now that are only doing high density foam, just so they don't have to bring 2 guns. They just, they'll do 5 inches in the end. He's like, yeah, it costs more for the high density, but we don't need 2 guns. But I save in labor and trucks driving. It's worth it to just do it that way.
And the fact that open cell foam is vapor permeable, then you would have problems with the dew point being somewhere in the foam.
What ends up happening is, it's usually somewhere around 6 to 8 inches. If you have 6 inches in a roof cavity, if you have 6 inches of 5.5 inches, you fill the cavity with low density. Generally, the dew point is far enough in that moisture gets in, but it eventually becomes vapor impermeable if you have enough of it. It doesn't work its way all the way through, at least not in one season. So it ends up drying in, drying out. It's never a problem.
But if you have a flashing leak or something like that, you're kind of screwed.
Yeah, that's another downside of the foam, is if you have a leak on the roof. However, over the years now, when it turns out, it still leaks. Just, it gets wet, the wood swells up a little bit, pops the foam away, and it just starts dripping and you shoot rock. Like, I've seen plenty of houses that had roof leaks with foam, and it just took an extra 2-3 months to.
With the high density?
High density, low density. Low density takes longer because it soaks in a little bit more, but eventually, just because the wood swells, it breaks free of the foam, and it ends up dripping around the sides.
Homeowners in England are covering low density spray foam. We're spraying all these old houses, and they've had massive rotting issues, so they're no longer covering.
The problem we ran into with foam is nobody really thought about dew point. Like, guys who were like, well, I'll just use 2 inches of low density and put that's it. Well, that doesn't solve anything. If you're gonna, you can't do it halfway. You kind of either have to go high density as a vapor barrier, or you need enough low density to give you a vapor barrier, which is, like I said, 6, 8, 10 inches, depending on the installation. Okay, ceilings. I'm gonna go with the assumption that you're gonna be putting equipment up in the attic. Most cases, that's what you end up with, so you're gonna go with the sealed attic. The upside is you spray the attic, you got a get out of jail free card on your blower door. Nothing leaks from the walls. Foundation is solid concrete, it doesn't leak. The only places in the entire building that are a problem are the entire ceiling plane and the little gap where the concrete meets the sill plates. That's it. That's where a house leaks from. Walls don't leak, unless somebody drills a hole in them, they just plywood, they don't leak. Roof leaks because this drywall gets floated to the top. You know, anybody doing the drywall here? You don't nail the top, because if you nail the top, it ends up a wrinkled mess, so you float the corners. So the top's where all my metal strapping is, where all my mismatches are, where all my protective plates for the pipes and the wires. So that top sheetrock is probably 1/8 of an inch, 1/4 inch out. Usually an 1/8 inch, 3/16. Well, I have an 8-inch gap that's open to the attic by 40 feet, 40 feet, 20 feet. I've got, by the time I'm done, I might have 1,000 feet of 1/8 gap up to my attic with fiberglass insulation. When I'm all done, it's a hole this big. You know, it's 1/8 times 1,000 linear feet. I've got a wide open window behind my walls. We turn on the blower door, all of the drywall dust from construction blows out from under the molding. That's how we used to find it. We just turn the fan up on high, walk the house and just look at all the streaks, take pictures of them, and then tell them, let's see, we got leaking acid. It's not leaking from under the molding, it's leaking from the top plate. You can do a vented attic. This one happens to be cellulose just because I didn't feel like finding a fiberglass picture. We don't do that much fiberglass anymore. You can do it. The problem is going to be that connection. Any place the drywall meets the top plates. And absolutely, if you don't deal with that beforehand, if you wait for the sheetrock to deal with that, you'll fail. Our failure rate, we say 95% fails on fiberglass. Fiberglass attics fail 95% of the time. We have, I think, 2 builders who can pass with fiberglass attic. They're both building multifamily, so the test is different. If they had to test those as a single family, they'd fail miserably. It just doesn't work. You've really got to, again, simple enough house, you can probably get away with it. Sometimes the insulators use sill seal, they staple it up, that kind of covers it. If you're working in fiberglass, this is what you need. Got this closed, I'll pass it around if anyone wants to see it. Great stuff, gasketing. It is not the crazy, nasty foam that you get out of great stuff that gets all over you and never goes away. This stuff is, it's latex, first of all, so it washes off with water. And I kind of blew up the can yesterday in the office. I went to swap cans, and the other one, the can I took off had been on there for a year, but the valve was stuck. And it just kept going. So I was covered in foam. Everything was covered in foam. Washes up great. This is dry for a couple days.
So you would shoot that along the top plate?
I would just, any place I had, along the top plate, especially any place I had strapping, I would just put a big fat bead of it. And then when they drywall, it just is a giant gasket. It's like a door gasket on a car. It just seals it up. It's nice because it's latex. It washes up easy. They give you a little adapter for the gun, so you can hook it up to a garden hose to clean the gun out when you're done. Case of cans, and we bought the case and the gun. We paid $150 for it a couple of years ago, so it's probably $6,000 today. With tariffs, it'll be $12,000. Absolutely. If you are doing fiberglass, you have to have one of those guns. If you're putting a fiberglass, if you're doing a vented attic, you gotta get one or two of those guns. You do it a couple days in advance. I did it in my own house. I took a piece of PEX pipe, piece of 1/4-inch PEX, and I heated it up and slid it over the end of that. So I had a pipe about this long, and then I was able to walk from the ground without a ladder. I just got 10-foot ceilings, I was able to do them without a ladder. You could do the top floor of a house with that stuff. You know, you can get a laborer to do the whole house in an hour and a half, 2 hours. Spend $100, $200 in foam. Okay. Somebody will recognize this picture. Other thing you can do is you can go passive house detail. Basically, you can vent the attic, do a traditional attic, especially if you have like a lot of funky ceilings or something. And then typical passive house, they plywood it, tape all the seams. You'll see that, again, guys who are like hyper insulating, where they want, you know, R80 or something. They'll do that much cellulose, but then to get the seal behind it, you can't rely on the drywall. So they plywood it first, tape all the seams, pre-test it before they close anything up. It works. It's a design, a style of building that you have to kind of be willing to do.
The reason why they have the vapor barrier on the inside?
Vapor barrier?
Zip system is.
Well, it's a vapor retarder, yeah, it's vapor permeable, Zipple. Honestly, it was, well, because they need a vapor barrier on the inside, but I think because it was just an easy material to get instead of using OSB, and because the zip tape sticks to it nice. Okay, works. The nice thing about it is kind of like this foam, you can test it before you drywall, so you can know you're gonna pass. This is like not a bad way to do it if you're doing old wood ceiling, because then you can just nail, you know, if you're doing tongue and groove wood or, you know, beadboard, something like that, it gives you a nailing surface on the inside. Sheetrock's a little rougher to work with, and you can't possibly put wood without something behind it and get it to pass unless you spray foam. Okay, basement walls. Basements, the insulation value went up to 19. However, when you do it in a trade-off, you can get away with a lot less. Typically, we still call it the 2 inches of high density foam. That's like my go-to. Personally, I like to see high density foam on basement walls. If you're finishing it, stand the studs an inch out, spray an inch behind it, an inch in front of it. It gives you 7 continuous and 7 in the cavity, maybe even 2.5 inches. You know, when you do the math, you might need a little bit more. As long as you don't have hydrostatic pressure, as long as you're not getting liquid water inside the building. And we're on sand mostly, so it doesn't really happen too much here. This is the best way to go. This completely kills the humidity in the basement. Moisture can't get in. All your wall surfaces are above the dew point, so you never have any condensation on the exterior walls. Again, if you're gonna have a guy there with a foam gun anyway, one shot they do this, and then everybody else does all the trade work. You close it up. You don't need to have insulators back, do fiberglass or anything else. I'm not a big fan of fiber. Let me go to this one first. Exterior insulation board. This only works if you're at walkout height. So if you're building where there's no steps, because if your concrete is out of the ground, that insulation has to be protected. So it's doable, but then you're talking about putting concrete board and stucco or something, or some kind of finish over it. So it becomes a little bit problematic. It's no longer just a cheap, easy fix, throw some insulation on like it would be on the inside. It's gonna work if your ceiling height, what we look for is if the ceiling height is below grade. Because if the insulation is up to the top of the ceiling, the foundation wall's done. The rim joist you could do from the inside. They could spray it the way they normally would. Usually you wouldn't see that detail. Usually you'd see it where the framing sits on a framing pocket on the interior. But that's about the only way you get away with just exterior insulation. Short of, like I said, going crazy with armoring it
Um, My least favorite, straight back. It's the cheapest. I see, builders will do it to get out of the jam because they didn't pass. They failed to blow it over because they did fiberglass. We added the volume of the basement, now it passes, so they staple that up in the basement. Downside to this is if air can get behind that insulation, which clearly it can, the air brings the moisture with it, and then it hits the cold concrete, liquefies, and you end up with dew behind the wall, which means you end up with mold growing back there. You pull this stuff off, it's usually really nasty behind it. And again, if you're trying to make the houses airtight, the last thing you want to do is make the house completely airtight and then fill it with mold that can never get out.
Could you use like rigid foam to get the 4x8 sheets and use that instead of those?
You could use rigid foam, but your foam needs to be, it has to meet either the ignition barrier or the thermal barrier. You can ask Reed about the specifics, but pretty much as far as I know, the only foam that would meet it code would be Thermax. Or the heavy foil, the commercial tough on. It's more expensive.
Really?
It's like $45 a board, and then you got labor to put it on. At that point, just pay somebody for 2 inches of spray. They're gonna have to come in and spray the rim anyway. By the time you're done gluing all of that on, it's like I see a lot of guys do it on, homeowners will do it, and I'll recommend they do Thermax. They'll realize that the blue stuff at Home Depot is cheaper. They'll put that on, and then they'll be painting 6 layers of intumescent paint on top of it to try to get it to be fireproof, and it'll look awful.
Wait, just sheet rock.
But they want to be framing.
Oh, because they're not using trim up.
Yeah. They could have done that from the beginning, but again, it's, what's that, Pennywise and, that's it.
Again, this superior wall, we don't have to worry about any of this.
No, you just use an insulated foundation. That's, one of the comment here was if you use the superior wall, those are the prefab foundations with the foam built on. Also, if you're using ICF foundations, a handful of probably they just, especially for like a crawl space, instead of bringing in a form truck, they could just do it with ICFs and pour it, then you have insulation in and out. The only downside to foam on the foundation is termites love foam. So you really have to make sure if you have foam coming up out of the ground, that your termite details are absolutely perfect, but they'll go right through the foam, right into your wood. I've worked on a ICF house that one of the charities had built, and they had termites in the attic 6 months after the house was built. They just ran right from the foundation, right up to the attic, and the only place they had termite damage was in the attic. And it was, and you're not allowed to use all those fun chemicals anymore, so it was really tough to get rid of them. Okay, once again, I lost track. There you go. There we go. Okay. Existing buildings. I'm gonna go through this a little quicker because it's basically the same thing over. This they added into code. This is something you see in South and East Hampton. They have the substantial reconstruction rule, where if it's more than 50%, they make believe it's a new house, and they make you do a HERS rating and the whole 9 yards. This is not that. All I found out of the entire code book about this is for alterations. I have a feeling this is things to come later, because there's a big push now that once you make a clean spot, you have to make the whole thing new. Big push for, because the way the rules have always been is if you open the wall up, you just have to put it back no worse than it was. Well, now they want, if you're gonna open the wall up, why don't you just do it right? Constitutional issue about property, nobody can tell me what to do with my stuff, but they're working around on that. It's starting to become a workaround, and they came up with this substantial reconstruction, or substantial improvement. And it's more than 50% of market value. And pretty much any construction you do is gonna be more than 50% of market value. It just works that way, because the cost of construction is so high. I have a handful of projects where they designed it, we modeled it, they priced it, they came back and said, we think we're just gonna go buy another house, because our addition costs more than the neighbor's house, and that's for sale, and it already has a pool. That was literally a conversation where They said that house down the road went for sale, and it already has a pool, and it's bigger than our house will be after the addition, so we just gotta move. So,
So the idea that would be like old house and the heights, 2x4 framing, if you're gonna do a substantial alteration, you have to.
no, like I said, there's only one spot in the entire code book where it comes in.
But you're saying they're working on that though, so that could potentially.
Yeah, oh yeah, guarantee, they already started with, it used to say it couldn't be any worse than it was. Now it says the walls have to be completely filled with insulation. And I called the state and I said, what if you go with high density foam? You would completely fill it. They said, well, as long as you meet new code, that would be enough. So you can either, you can either put R40 high density foam in the attic, or you can fill the cavity with R3 insulation. You can't just put back whatever was there, not any worse. They took that out already. Okay, additions. Anything new for addition gets treated like new construction. Same rules apply. You don't need a blower door. Additions don't get a blower door. Only new construction, only a whole dwelling. That was in the code from 2016. Didn't work, messed up everybody. It's gone. It was gone for 2020, it's still gone. Blower door is only for a new complete dwelling or a complete build. Doesn't even have to be a dwelling. If you're just adding, it doesn't count. HVAC gets a little tricky. If you put in a new system in an addition, it gets treated like a new system. Has to be within the thermal envelope. That's one of the rules. So you do an addition on a house that has this vented attic, your ductwork can't run from the existing vented attic into the new vented attic, because that new attic would have to be sealed, or you'd have to find another place for the ductwork. Like I said, it gets wonky and tricky. A lot of times what we're already seeing where they had like the stretch code east in Southampton, the guys would run, when they got to the addition, because the rule said, even though as silly as it sounds, the rule said the addition has to be within the thermal envelope, they go to oval duct, lay it against the ceiling, and it's straight foam over it, so it's within the thermal envelope. Even though it's connected to a piece that's sitting in an open attic. But again, it's a rule, we have to enforce it. Duct systems have to be in conditioned space. If the existing heating system is extended, you don't have to test it. Used to be if it was 40 feet of ductwork, we were supposed to test it. The problem is if you have 40 feet of flex, how do you test them without disconnecting it all and then test a piece of flex that clearly doesn't leak? It was a really stupid idea. They took it out. Now if you connect to an existing system and extend it, you don't have to duct test it. It still has to be within the thermal envelope though. Okay, here's the one we wanted. 5 additional credits. If you get 5 credits, you need 5 credits for an addition. We start with that. If a new construction, you need 10. For an addition, you need 5. If you don't put any equipment in, you don't need any credits. They don't make you put equipment in. You don't have any equipment, you don't need any credits. However, if you don't get any credits, you can't get that wall exception, that opaque wall exception that we want. So you can't get the opaque wall credit unless you have 3 additional or use a heat pump, the same rules. So you're building an addition, you're either gonna need that crazy wall insulation, which is gonna be difficult, or you're gonna have to put in equipment. I've had a couple of projects where they're like, well, we're just putting in one room, put a mini split. Get all your credits, you get the wall exception, instead of running a piece of flex, put a mini split. Put a cassette if you don't wanna look at it. We're kind of stuck with it. It's one of those rules that only works sometimes. Alterations. This is where that substantial alteration thing came in. Only spot. If it's considered substantial, you need to get 3 credits. If you get 3 credits, you can get 6 credits and get the wall exception. Then you're back to the R20 wall. So pretty much, I would think every alteration is gonna be a substantial one. It's gonna both be the most expensive 2-foot bump out I ever built. Because I really would wanna put some kind of equipment in and get that credit. I have a couple projects where they just broke down and said, yeah, we're just gonna go 2x8 walls. Gonna do a 2x8 flash and back, because it was just not that big a deal, you know, they switched, there's only a couple feet of walls, they went to 2x8 framing, they got their R36, and they were done.
So are you using the word alteration as actually adding square footage, or are you using
No.
alteration with no additional square footage?
Alteration is, you open it up, and you put it back together,
No additional square
no addition. Anything additional is an addition.
footage?
So, the other
It's
thing.
not repairs, it's alterations, and there's alterations 1 and 2, and 2 is if you reconfigure the space. Basically, that's.
Yeah.
So if you're putting in a kitchen, Rich, like,
If you're changing the layout, if you're changing the wall, interior walls or doors, right, then it's alteration 2. So if you're doing a kitchen, yes, that's an alteration 1, if you don't change the walls. So yes, the short answer is kitchens are unfortunately alteration.
For us, for energy code, if you open the exterior wall, I don't care about the interior walls at all, they don't exist. The exterior wall, if you take off the sheetrock, that's gonna show up in a res check as an alteration. Anytime you think about the old res checks, it said walls were opened, insulation wasn't changed, walls were open, insulation was returned, exempt either way. The rules got a little stricter for that. Mostly this comes in when I'm replacing, like, I want to take down the ceiling and wall it. Well, if I move this ceiling to the roof, that's a new structure. If I change the roof and it's insulated, that's a new structure. As to what specifically constitutes what, that would be the building department.
I've had classes
Yeah,
where they discuss existing building classes. And I've had arguments because one teacher, New York State code enforcement expert, has said that if you remove any sheetrock, it's alterations. And the other said, no, you're allowed to remove sheetrock, and it's not alterations. There's a lot of, it's open to interpret, a lot of it's open to interpretation.
at the end of the day, for us, anything that's new ends up being something I need to deal with. Anything that's existing pretty much ends up just being, you need to re-insulate. You wouldn't need a res check if you were gutting a house and not changing anything. Because you'd just be re-insulating when you're done. You know, it'll be prescriptive completely. You write it on the plans, there's no math involved. They have a res check for alterations, but it basically says exempt, exempt, exempt. New windows, and each individual window has to meet code. Each line item has to meet code. You don't get any trade-offs on alteration the way you got them. You can get like area weighted for windows, but if you can't say, I'm gonna put less in the attic and more in the walls. For an alteration, anything that's new has to meet code prescriptively. Anything that's existing, you open it up and put insulation back. That's the only thing that they'll say is that you have to put in, you have to fill the cavity, it has to be at least R3. You know, if you open up the ceiling and it was R19, you can't put R19 back. You have to fill the cavity.
While there are less and less of them, is there any provision for alterations to a seasonal building, like in Shelter Island Heights, where you have,
No.
so like if you did something in a cottage that has no interior cavity, you know, the exterior sheathing is the interior finish. What happens?
Yeah.
Single wall.
I can't out.
Single wall construction.
And the problem is, basically, we're gonna interpret things as liberally as we can. However, we now, especially in the energy code, they come in every 2 or 3 years. They want us to bring pull out all our new files for each thing. And they go through and they arbitrarily pick 4, 7, and they check us, they audit us. And then we can lose our certification as inspectors if they find that we screwed something up. It's not like it used to be.
So there wouldn't be any inspectors here?
There wouldn't be a building. It's not as good as it sounds.
I can tell you a story, when we first started doing this, Long Island, most of Long Island towns went to Energy Star. So we were testing, this was 2009, and they got a couple bucks from LIPA, and they all jumped on the bandwagon, gonna save the world. And New York State got a lot of money from the Obama Green Jobs, Green New York. And one of the stipulations is you had to show 90% compliance with the energy code. So the feds came in and said, okay, let's see your 90% compliance. And the state went and said, here you go, here's 6 Long Island towns. Everybody, look how wonderful we are. And then the state said, well, maybe we should check the rest of the state. And people were like, testing? I did a class for Westchester. This was 4 years into the code. This was the 2016 code. And they were like, we don't do any of that. You do now. You're supposed to be doing it. So what they did is they just said, okay, we're gonna check it. 2016 code. They went through town by town and they audited everybody. And they said, we're gonna ignore everything that happened before, but we're gonna look at everything that happens after, because we know nobody was doing anything. People were, upstate New York was absolutely, completely ignoring anything that had to do with energy. It's the law. Yeah. But Westchester isn't. That's about it.
Is there a historic carve-out?
Yes.
Landmarks?
The historic has changed, and honestly, I haven't put as much time into that. There was always a historic, basically anything that would change the character of the building, you don't have to do.
But the caveat is you have to be on the National Historic Register. It's not just a historic house.
Yeah.
You have to be on the National Historic Register for the historic building code to apply. And there's like, we got about 2 of them on the island.
Yeah, there's a couple of different
Sylvester
options,
Manor,
but
they gotta.
yeah, if it doesn't have a plaque, you're not getting it, basically.
And and the problem is, it sounds great, I'll go get a plaque. If you get a plaque, then the feds are actually overseeing that you're meeting the limitations of the historic
But
building.
then they have to approve your paint job.
I mean, it might even be worse than the internet.
If we're doing an addition to a house, does that need a HERS rating, or does that can get away with just a res check?
HERS rating is only for new construction. And I don't know how you're gonna handle.
I don't know how we're gonna handle that quite yet either, but we, in other words, we wouldn't be requiring a HERS rating, but we might, I think what we're gonna do is require someone like.
HERS rater.
A HERS rater, in fact, I know that's what we're gonna do.
Yeah.
We're not requiring a HERS rating, we're requiring a HERS rater to do the final sign off, basically on these things, because it's too complicated.
This method, it's how we do it. All the Nassau counties set up like this. Brookhaven, Shelter Island Heights, I think. I know George. Terry Hart and North Haven. He requires a HERS rating, just for the exact same reason, just to not have to deal with
I
it.
think we may be the last town that's.
Sagaponic
There's a couple of villages, Islip doesn't, and Riverhead doesn't. Everybody else, so that's a village. I mean, there's a lot of villages that aren't. There's, I don't know, it's like, how many villages are there? 50 something. There's a lot of villages, and it's hit or miss. We go through, like Great Neck has 30 or 40 villages, it feels like, and they all have slightly different rules.
Are you the rater or is somebody else the rater?
I am the rater.
You're the rater.
For our company, myself and my partner are the raters, and then we have field inspectors who are also certified to do all the testing. At the end of the day, I have to sign off on the calculations. They are OCD about their paperwork. ResNet, the overseeing organization, he's not allowed to type the numbers into the software because he's only a field inspector. You'd have to have a modeling certification to be able to type into the software. So we just do it and don't tell anybody, because at the end of the day, I have to sign off on everything because I'm the only rater who can put their signature on it. They've just gotten a little carried away. The good news is you end up with, it's really hard to cheat the system. Every 1 out of every 10 jobs, they randomly pick and check all my math, check the plans, check my pictures, make sure I took pictures of everything that had to be inspected. And if I don't get everything right, they put me on double secret probation.
And then when we get audited and they find a screw up, we say, well,
Yeah, that's, if you want to get really back to the beginning of this, basically the towns just said, we don't want it to be our problem. They passed it off to us. And I'm signing off saying everything that's in the energy code, I'm checking. And we do. That's kind of part of the rating is we actually have to go up in the attic and check everything. We check and test, and we have model numbers for every appliance. Everything gets tested. Everything gets documented. We end up with 300 or 400 pictures for every project.
We couldn't possibly do all the testing and all the reconciling of equipment, and it just isn't, we got 2.5 billion.
The biggest thing is continuity. What we find is with all this testing, the odds of getting it right at the end, if you didn't argue with me at the beginning, odds are you'll screw it up at the end. So, at the beginning of the job, I want to use this, I want to do that. We spend a lot of time getting new lists of materials. I've got like contractors that'll run things 6 or 8 different times. What if we did this? This will be $20 cheaper, this be this per square foot. And I'll do all that modeling again. For me, changing values is a library entry. Once I have the shell design, once I have the model done, you want me to switch from R21 to flesh and that, I just drop down and click on it and it's good. And then I can run it again, see if it still passes. So we do a lot of that, a lot of value engineering. But if you don't do that and you get to the end, it's a crapshoot whether you're gonna pass.
So he doesn't have to go to the eye shop at the IGA, I do.
Is that only on the final or is it on the pre?
What do you mean,
Additions?
What?
When you're looking for a rater?
No, there are gonna be 3 points at which we're gonna look for something from the HERS rater. We're gonna look for the initial application that he's going over it and attest to the fact that, and he's not the only one you can use. I would say that you're not gonna find anybody worse, anybody better.
That was for you.
They're gonna find anybody better. But, so he's gonna submit with the plans, basically the equivalent of the rest check, just a little more involved. Then, before we do our open wall inspection, and close up the walls, he's gonna come in, he's gonna leave a little, he's gonna do his inspection, tell you what you need to do. And then he's gonna leave a little,
Just like your electrical
Yeah.
inspection sticker.
Yeah. He's gonna leave a little
Still have another one like that lists all the insulation. And at that point, we look at what you did versus what was drawn. We take all of the actual values, run back to the office, model them in to make sure you still pass. Big difference, so we have to be there. The other thing is, if we're not there before rough, there's a good chance it's a crapshoot at final if you're gonna pass. Because once you close the walls up, I can't find holes.
So you only didn't look at the plan when you were building.
And
We
also,
look for, right, we look for the plans, and then we ignore them completely, and then.
and also at that point, you're gonna be checking doing the actual testing on the ventilation.
Yeah, what we'll probably do, and this is gonna depend, really job specific, on the bigger projects, we're gonna test the ductwork when the HVAC contractor calls us separately. I don't care if the insulation's in, I wanna test that ductwork whenever it's the most convenient for everybody. We'll come in, we'll plug all the holes with foam, pressure test it, and it's done, we don't ever have to look at it again. If we wait till the insulation's in, then if there's a problem, somebody's gotta climb through all that insulation. If we wait till the walls are done, we can't test it anymore. We could test it, and if it fails, you're either climbing up in the attic or you're ripping the walls open. So, coordinating this, it's really a chance during the rough to take care of anything that could be a problem. With the insulation, especially spray foam, there are specific, if you're building a FEMA lift, there's a good chance you're gonna have a problem even with spray foam. Because some of the things that you don't think about where the actual finished basement spot that you're just calling entryway connects to the
unfinished spot where your ductwork goes through the ceiling cavities. All of those holes, it's inside and outside, even though it's still in the basement, and everybody misses it. I go back and the thing fails miserably, and we're generally opening up ceilings and finding big holes that somebody can climb through that, the HVAC guys made or the electricians made to get pipe in. Anytime if you have a porch, with spray foam roof, and your porch overhangs, well, that soffit is part of the house, even though it's over the garage, it's over a side, it's over a porch. Well, if you're spray foaming the roof, you have to spray foam that ceiling. Many times, spray foamers spray from the ground, so they don't even notice it. You just miss it. We climb around in the attic and find it, so that you don't fail at the end. We get a lot of fails. We get a lot of FEMA fails. Anytime people had like wrap around on the eaves, they have those little, on the gable ends, the little cornice that wraps around, a little detail. As those wrap around, the spray foams notoriously don't go around the corner, and they leak like a sieve. Easy to find it rough. At final, we're throwing smoke up in the attic, and you're watching it pour out from around the gutters, and then somebody's crawling in there to try to fix it. So it really helps to get a rough inspection. Okay.
So as per your suggestion about getting the 2 inches of foam in early on.
All right. No additions, though, what you're gonna do
Would
is.
you get in there and look at that? That's where you wanna look at?
It depends on the bill.
Before you start putting the bats
It
in?
generally depends on the bill. If you're building a box with a roof, we could walk in after the fiberglass is in. You got something with balloon frame walls, 2 stories and connections and roof lines, I'll come 5 or 6 times if you need to. I'd rather find it now than spend a day crawling around in an attic trying to find it after. I mean, you can ask Tyler what it's like when one fails and we're trying to find it.
I remember what it was like.
Yeah, it's rough. So,
I just want to clarify, for additions, 3-point, or that's only on new build?
No, it's not gonna be 3-point on new build.
right, the first point would be rest check instead of a hard
In
check.
other words, you get,
You gotta have a rest check either way.
it'll be 2 basically, I
Right.
guess.
It's still we do,
They'll still be doing what they do, but
right,
we don't get.
the first part, the rest check could be anybody, it doesn't have to be a hard grader.
Or you would notify?
Yeah, we're gonna show up at least twice. The first part would be the paperwork. That first point of the 3-point is the paperwork that you're getting from us instead of from the architect or whoever did the rest check. But other than that, it's basically the same. Okay, ceilings. One of the new things they said, cavities need to be completely filled. If you open up a cavity and put insulation back, if you took out 19 and it's a 10-inch cavity, you have to put 10 inches back. And the insulation has to be R3. So you have to use like fiberglass with minimum. If you don't fill the cavity, then it has to meet new code. Like if you open up a wall and it has, you open up a 3.5-inch wall and you say, well, I'm gonna do high density foam. I'm not gonna put 3.5 inches and shave it, I'm gonna put 3 inches. Well, that's R21, that meets the R20 requirement. So that meets new code even though it's not full. If I'm doing a roof, I need 40, or I need to fill the cavity. So I could either put 10 inches of low density or fiberglass, or I could put R40's worth of high density and leave it half full. That's all. You either need to fill the cavity or meet code. This is the new one. If you're altering the roof, any alterations need to meet new code. So if you're adding a doghouse dormer, that's an alteration or, an addition, if you would, that needs to meet new code. It becomes tricky when people are tying in an addition into an existing roof and they're redoing the roof. Like if you're redoing your roof, or you're redoing the roof from the inside, you're redoing the framing, it's a new roof, needs to meet new code. If you move the insulation up, and this one, the insulators are flipping out about, if you just decide to take an existing house and do a hot roof on it, the hot roof can't be R30, it has to meet code being R40. So that ends up being a big one, because a lot of times the roof rafters aren't big enough for R40, so they either need to keep going right over it, or they need to go high density foam, and it's more money.
above grade walls, same thing, must be filled or meet new code. And here's the tricky one. This one is absolutely a nightmare. If you strip the outside, if you pull the siding on any elevation, they don't say the whole building. So if you clear an elevation, if you strip the siding and change the windows, the entire assembly needs to meet new building code. So if you need to put exterior insulation to do it, they're figuring now's the time. Absolute nightmare. Because in theory, it sounds good, except the cornices don't work. Your connections on all the sidewalls don't work. You have to change all the doors too. Yes?
I have a question, because it's gonna be a nightmare for us to enforce, because we'll be all hit. Is there like a look back period, like if they do the windows and then they wait a month and do the siding? If they do it on two
Probably-
separate permits?
Probably if it's two separate permits, I've actually already told 2 clients to
Do it on
hold
two
off
separate.
on, yeah, hold off on the windows, or hold off on the siding,
Siding, yeah.
one or the other. And, because they were gonna re-sign
Once
the
the windows
windows.
are done, get signed off,
Or,
do the siding.
I've actually had one where they said, well, we have one window it's kind of like in a different area, so it doesn't matter if it looks different, so they left one window. So it didn't meet the requirements, and the town said that's okay. Because it says all the windows and the siding, so they left one window. Now, that one window is gonna look completely different than the other ones, tint's gonna be different, but for whatever it was, they thought it would be okay, and they went with it. Yeah, this is.
We're looking for a way, we're looking for
Yeah.
pleasant and deniability.
That's it. This is gonna be one of those, find a way around it instead of doing it.
So if you're re-siding, it's windows and wall coverings, not just like you're re-siding a house.
Now, windows and siding.
On an elevation,
On one elevator.
yeah.
And so just that elevation has to
Well,
meet, or
Yeah, no, but if you did half of a wall, it doesn't have to. You know, if you did the first floor, only changed all the windows and re-sided, you don't have. If you do an entire elevation, one whole side, that entire side needs to meet code. You don't have to do the other 3 sides, but
Not just in the area that you're changing.
it's
So,
only if it's an
so if you're
elevation.
re-siding a house and putting in newer windows, you're gonna have to bring the insulation in the house of the code, which means stripping all the sheet rock.
It's like a whole,
Everything.
Well, they want you to foam it from the outside.
That's a big thing.
probably the
Yeah.
biggest.
Yeah, so when is this
Nightmare.
we applied for a permit for this 4 months ago? Are we, when did that start?
December 31st was the date. That's why
That's gonna change.
we got like 500 applications,
Yeah. but-
December 28th. So we're,
December 31st, 2025.
anything after December 31st is the new code. As long as you have substantial application before December 31st, we got all kinds of half-ass, applications that need to be, but
Yeah.
it's like, that was the,
I can honestly say I had a handful, not here necessarily, but in one of the Hamptons, that they submitted the same plan with 5 different addresses on it, you know,
Right.
actually 3, I think it was, that he did. And he just said, well, at least we'll be in, we'll have a date, and then we'll just revise them and send a new plan. Because at least they got in before. And then it turns out, with all of this, on new construction, nothing really changed. If you're in the Hamptons on a stretch code, nothing really changed. Everybody was doing this already. There's nothing major. This is really gonna kill the people who were doing the minimal. If you were building fiberglass and kind of, not going crazy, just kind of as little as I can, build it to a spec housing. This is gonna be problematic. You're gonna have to up your game. If you were already doing spray foam, it's minor changes.
it's really designed for commercial builder. In other words, on the low end, it's only commercial builders that are doing like
Yeah, exactly.
1,000
The
houses.
spec builders who are building,
Yeah.
I have guys who still build with 2x4 walls, who are, we're doing fiberglass up until I told them I was not gonna be their raider anymore, and I just was tired of it. Then they started spraying the roof. They're still using the drape bats in the basement because it's cheaper. But a lot of guys build like that. And honestly, if you're building, someplace like Brookhaven, you can't build for less than it costs to sell, you can't sell it
for more than you're building it for. Like, there are a lot of builders who are just like, there's no more money in this job, it's just, I can't,
Too expensive.
you know, they're gonna go back to Formica countertops with their other choice, I don't know where you're building. Okay, additional stuff. Okay, one of them was, and this is kind of another reason why we're getting involved in this, these open wall inspections are mandatory. You close the walls, we're supposed to make you open them back up. But they have a name for it, it's like a destructive something inspection. Basically, you have to tear some sheetrock down to inspect it. And keep in mind, the way this works is I can't sign off on something unless I see it. And if I don't sign off on it, he's not gonna take it. So basically, if you don't get a rough inspection, you don't pass. You're gonna be opening walls up.
So PFS will do the rough inspection and that's okay?
Yes, modulars,
Okay.
modulars are rough inspected at the factory. The state signs off on that. So yeah, that doesn't apply. However, if you're finishing a second floor, you know, if you have a stand-up roof and you finish the attic, that has to be inspected, so then we have to be there. Yeah. Okay.
Still.
Infiltration testing, this doesn't really affect you guys. I'm just gonna really go through it quickly. They changed the way we test. Blower door, the final value is exactly the same. 3 air changes, hasn't changed at all. The difference is they gave you the option now of leakage per square foot of surface area versus leakage per volume. Small houses used to get hammered. At a small house, you have a lot of surface area and very little volume. The bigger the house, the more exponentially the volume goes up without the surface areas going up. So on a giant house, 3 air changes, you can leave a window open. On a small house, 3 air changes was tough even with spray foam sometimes, especially like a little, 600 square foot units. So they've given you the option now of leakage by surface area. For any normal size build, 3 air changes works fine. When you start getting down under, say, 2,000, 2,500 square feet, depending on the shape of the house, sometimes surface area works better. Like if you have a ranch where there's a lot of leak, a lot of potential areas for leakage, I could use the other method. If you're building small, under 1,500 square feet, I get 0.27. That's almost what multifamily was. You could almost get away with fiberglass and not doing a good job and still pass on a tiny build. This is a big help for small builders. It was so unfair that I could, if somebody builds 30,000 square foot house, they could forget a window and I could still get it to pass. You build something tiny and you dry vent this open and you fail. So this will definitely help.
It's gonna help with ADUs a lot.
Yeah.
There's a big push here for ADUs.
Yeah, when you start seeing like,
And it's almost impossible with previously to get a small, not impossible, but very difficult to get a.
if you're building a, over two-car garage, like really common, little apartment over 2-car garage, this will save you. This will make it an easy pass instead of an almost impossible pass. Duct testing, okay. Everything gets tested. We kind of talked about that already. The way they did this is they said, if it's not in conditioned space, which is like if I was putting a new duct system in an existing house, that doesn't have to be in conditioned space because the house is already there, but the duct system has to be tested, has to still hit, there's kind of the same numbers we had before. If it is within the thermal envelope, it still has to be tested, but leakage doubles. Instead of 4 CFM, now I get 8 per 100 square feet. So that's a lot of, it's like a lot of leakage. You could have just a decently put together system that might leak a little bit around the edges, and it's gonna pass. And it's only leaking into the building anyway, so we don't really care. If you have more than 3 returns, the leakage triples, you're allowed 12. So I'm not really worried about anybody's duct systems failing. I'm worried about being able to test them. It's really gonna be a matter of getting me there the first available duct test time. As soon as the system's in, we'll get in there and test it. Because otherwise, we're kind of hoping at the end that we can get it to pass. This is my big issue. Linear registers with custom paint jobs. If I show up at the end, before I'll test that, I'm gonna want somebody to sign a waiver saying if I ruin the paint job, I'm not responsible. Because I don't wanna be touching a custom paint job, you know, I have to tape those registers over, that's a linear over the door. How am I gonna do that? I really need to do that at Rough. But if they don't call me until final, you know, we use the slightly sticky saran wrap tape, like it comes on a roll for kitchen goods. We try to put that on, and I'm still worried about taking paint off. Or if you have registers in the kicks under the kitchen cabinets, well, if you just cut it out, and, you know, technically you're allowed to just stub it out in the floor and have it blow out of the cabinet. That's not a framing cavity. So I wouldn't, you know, again, I don't know, maybe it's not allowed, but I don't argue with it. But if I can't test it, it fails. So you have to be either taking open the kicks or taking off the cabinet for me to be able to test it, or ripping it down from underneath. So we really gotta get the testing to happen when it's all still available. At Rough, we have blocks of foam. We just block it all with foam and pressure test it. We don't have to tape anything. It doesn't have to be sticky so we can kind of work in a rough environment and still duct test. Once it's final, you know, once it looks like that, then it's kind of not on me anymore. All right. This, actually, you have till tomorrow. Deadline's April 3rd. Today's the 2nd. Governor Hochul put this express New York. Did you end up?
I haven't written mine.
I wrote two.
Did you?
I
Can
just,
I have one and I'll?
I complained about duct testing, about how it's a waste of time and money. This is how do you streamline New York State regulations? So the first thing I complained about was, and you basically have, it's just a form that pops up and you put in your name and phone number and what what you'd like to see streamlined and why you think it's a waste. And it's kind of designed for, like, you know, social services and things like that. But I'd like my building codes streamlined. So the first thing I complained about was duct testing, because if it leaks into my living room, I fail. It just seems like a waste of time and money. The other one was windows. If you guys are building coastal, how much coastal glass is required around here? You're on a little island?
We accept panels.
Panels. If coastal glass, there's an exception in the code that says you don't need to use .27 windows for coastal glass because it's not available. If you're in climate zone 5 and 6, where there's no coastal glass. Turns out when they copied the international code, climate zone 4 was a 0.3 and it was available. Climate zone 5 and 6, it was a 0.28, it wasn't available, so they gave the exception for those two climate zones. When they copied it over, they never changed the footnote to include 4. I talked to the Department of State, DOS, and they said, oh, we'll be sure to be advised of that for the next code cycle. But in the meantime, if you need those windows, you have to file a variance with the state.
Gosh.
So my other complaint was, why don't you just make it a permanent variance for everybody who needs? Because
They should at least do it as an administrative variance.
which
It's ridiculous.
they might do it that way. My thought would be they won't do it that way until somebody pokes them. And in the meantime, it'll take you 6 months or a year to get a variance for your windows, and people will be putting panels up that they end up using for scrap wood and burning the fireplace. And that's the impact glass is nice, but you have to be able to buy it or you can't use it. Okay, ventilation. This is where we get into what were they thinking? You can't put a light switch on a fan anymore. Your choices are primer, occupancy control, humidity control, contaminant control. I've never seen contaminant controls for houses yet, other than pretty elaborate PM 2.5 systems. Basically, it's going to be a timer or an occupant sensor. My guess is everyone's just going to go to the push button at 20, 30, 40, 60 timers. They don't want you leaving the fan running indefinitely. And I'm going to talk about fans in a minute, so you'll see why they don't want you leaving the fans on. Mechanical ventilation systems need to be tested. if it's a bath fan, and this is my take on it, is if the bath fan is required for mechanical ventilation. In other words, if there's no window in the bathroom, that fan is the only ventilation for the room because there's no window. That fan needs to move 50 CFM.
Talking about operable windows.
Well, yeah, with a ventilation window. If you're gonna have an outside wall in a bathroom, it pays to have an operable window because then you don't need the bath fan to
Well,
pass.
a lot of my clients build 9-foot high ceilings and the windows above the shower, you can't even reach it.
No.
You don't have to be a local, it just has to be there.
Well, it has to be an operable
Yes,
window. It
yeah.
has to have the required ventilation. You know that light and vent sheet on the plans that I don't read? That light and vent sheet says how much opening you need for each window. If you don't have that window, you need a fan. If you need so in other words, if you have a room with a window, bathroom with a window, that fan doesn't count. It's only the ones like powder rooms. The problem is powder rooms tend to be the ones that are absolutely the furthest away from the outside walls, which means you have 497 and a half feet of duct going to them. And you put that fan you put in that's, 50 CFM, $29, puts out 6 when I test it. And you fail, and we got open ceilings up. Is this gonna work?
But if you put a fan in and it's not in because you have a window, you still need to put it on a timer.
Yes.
Yes, but you don't have to have it tested. And the testing becomes more challenging because now you're not going off, oh, I have a 100 CFM fan. You're actually gonna have to test it and it could still fail the 50.
I can tell you, we test.
Because of all
He
the-
tests a lot of fans. Panasonic 150 CFM fan, what would you say the average is?
For Panasonic,
70,
80, 90.
maybe 80.
Yeah.
150 CFM fan. An 80 CFM fan, 30, 25. 50 CFM fan, usually we can't get a reading. Zeros, we just.
gotta overdo it, right?
Well, we set up, we are.
See that?
I brought a fan.
Another small child.
Can you guys hear that? Yeah. I specifically brought this one, it's defective, it makes a lot of noise. However, it moves a good amount of air. You can see it coming up here. This is a 100 CFM fan. It's rated at 100 CFM fan, connected at 0.2 inches, which is like duct value. It's rated at 80. There's no duct connected to it yet. Just listen to this as I connect the duct. Okay, notice it's not moving 100 anymore. Now, you hold this end, just so it doesn't go anywhere. Flex hose. We have an HVAC guy here. How much air would you normally put through a 4-inch flex if you were hooking up your AC unit?
Sure, honestly.
40 CFM?
I was gonna say about 40, 50 CFM.
Not 150 from the patent. And the blower rise HVAC unit is a little more substantial than your Panasonic fan. You're never getting pushed this much static pressure with that fan. If I get this really straight, you can hear it, except I'm not going to get it that straight in the wall because it has to go up here and down here, and you suddenly see what starts happening. It starts plummeting. And this is a 100 CFM fan, and I'm just about not passing. And this is 22 feet of ductwork. I've tested fans that had 75 feet of 4-inch ductwork. And here's the rule of thumb.
No more CFM.
The louder the fan is, the less it's doing. Not the other way around. Like, wow, it's really pumping. No, that thing is just fighting. It's not doing anything. This just it can barely even open the flaps. That's how little force this fan has. This was a 100 CFM fan. Powder roof fans, if, like, as we test them to use from whole house mechanical ventilation, they always fail. Oh, they never hit 50. The only time is if I get a guy who puts in a good Panasonic fan and puts in 6-inch ductwork. But no one ever wants to put 6-inch ductwork because they got to snake it around half the house to get it out. So they put 4-inch, and then they do this with it, and they end up with no air. I mean, you can see what I'm at. Well, now you're at 0. This is, picture it comes out of the ceiling like that. First thing is an elbow. When you do static pressure, New York State Code says an 80 CFM fan is allowed to have 4 feet of 4-inch duct. Any more than that, you need to go to 5. That's for an 80 CFM fan. Each elbow is good for 15 feet, I believe, 25, depending on the type of elbow, 15 feet per elbow. So if you come out of your fan and make an elbow, you already have 15 feet. If you have a flex, half, whatever your length is, double it. Because flex, they're talking about hard pipe. Flex pipe gives you twice the static pressure, half the distance.
I guess if you close your bathroom door, the toilet's going.
Yeah.
So if this doesn't work, then what do we do?
Expands here.
He talks
More
about
CFM.
kitchen.
Well, kitchen fan,
Kitchen fans, what about like range hoods? They always seem to be.
if it doesn't vent out, here's my suggestion. If you're gonna vent your microwave, when I get there, have it blowing back in, don't flip the fan. Because if you have a microwave fan blowing up into the duct and through the kitchen and out, it's never gonna move 100 CFM, and it's gonna fail. But if it's not vented out, then I don't have to test it, it doesn't count. Number 7 on the stupid rules from New York State, but it's a requirement.
Range hoods?
Range hoods. If they don't vent out, we don't have to test it. If they do vent out, they have to move 100 CFM when they fail.
I'm not talking about a microwave fan, I'm talking about just a regular range.
They need to move 100 CFM.
Okay.
Yeah. And typically, unless you're buying like the old school painted metal ones with a little fan in them, which nobody, I don't know if you can still get those. It's not really an issue. It's an issue when you have 400 feet of duct on it. I think there's a limitation. It's if it's, I don't remember off the top of my head. Again, I haven't started testing them yet, so it's not in memory. I believe if the duct is bigger than 6 inches and has less than 1 elbow and 15 feet, we don't have to test it. It's like, if you're coming in and out, if it goes into the kitchen hood and right out through the wall, we don't have to test it within some limitations. I don't remember what they are.
Did they change the makeup air requirements though for, in other words?
That's next.
Okay, sorry.
That's next. These little ridiculous, the fart fans we used to call them, the idea was to make enough noise that nobody heard you fart. It wasn't about moving air. It's not really cut it. This is my analogy to it. SPF lumber. Anybody frame with SPF that a Douglas fir? You even allow it? It's allowed by code.
Yeah, no, and actually, some people swear by it.
Yeah, it's allowed, but we don't really do that. You could use tough bar instead of sheathing. It's allowed, but we don't really do that. You could use vinyl tile. It would be a real hard sell if you're trying to build a new house and put down, peel and stick tiles for micro countertops. None of this is required. We don't need any upgrades, but we do because we don't build like that. And then we put in a $21 bath fan that does absolutely nothing except make noise, and every burrito that anyone's ever eaten is still in that bathroom. I'm a firm believer in big bath fans. I actually have the math for it. There's math for burritos and bath fans. You take, pretty straightforward, you take the volume of the room, we work in half-life. I'm never gonna take all the air out of this room, but if I mix in half the air, well, then the concentration will be half. Because I'm not gonna, the air's not gonna be replaced, it's just gonna keep mixing. So we kind of do it like radiation, you work in half-life. You assume volume of the room divided by 2 is on about half the air in the room, minus the fan, divided by the fan CFM, tells you how many minutes. And then they have the mix factor, K. Basically, that is how much air you're moving, and will it just stagnate or will it mix? So a small fan is going to have a really poor mix factor. I did my own animation here as best I could. Don't make fun of me. I'm moving a fan, I'm moving, that 50 CFM fan that's barely moving 50 CFM. A little bit of air is going to dribble from my duct, whether it's on or not, because it's going to be the biggest hole it can drag air from. So it's going to dribble a little bit of air across the ceiling, and a little bit's going to come out under my door, because that's the only 2 gaps in the room. Now, I'm only moving 50 CFM. I got a slot this big and a 6-inch vent, or even a 4-inch vent. It's going to be trickling. I have no velocity. If I don't have air moving, it's just going to stratify. I'm going to have a little puddle of clean air here and a little puddle of clean air on the floor. And my burrito is still going to be right smack in the middle of the room. I put in a really big fan, I can up the velocity on those 2. Now I get the air to swirl. I need that speed to get the air to mix. So a small fan, even in a small room, I just end up stratifying it. So if I'm willing to crawl around on the floor, I could breathe like a fire. But if I'm up at eye level, I'm going to be breathing in last night's dinner. The fact that they use a 0.5 for a low velocity fan, up to about a 0.9, that's about the best mix you'll get. If that's what an air conditioning guy would be looking for. He'd be looking for a 90% mix if he gets his air to swirl pretty good. So if I throw that in, this is for 5x7 bathroom, 8-foot ceilings, 50 CFM fan. Do the math, works out to 5.6 minutes to get half the odor out. I could reduce by 50% the odor in 5.6 minutes. We typically want we want 5 air changes for odor, 10 air changes for moisture. Moisture is a little different because you take a shower in a bathroom, a lot of that water is clinging to everything. So even after I clear the air, the moisture goes back in and it's damp again. And I need to keep clearing it. So we want 10 air changes. So we're now looking at 28 minutes or 56 minutes to take the moisture out. If you're sharing a bathroom with anybody, 28 minutes is way too long. And you'd say, well, big fan. Big fan is very big fan. We're also assuming 50 CFM is what's going to come out of it, not what it said on the label. And we already saw that 50 could be half that 28 minutes could easily be an hour before the room doesn't smell. Do the same thing for a 10 by 12 master. I put a 200 CFM fan in this room. Just to do the math, 2.4 minutes to reduce the odor by half. 12 minutes to reduce it 5 times. So basically in 12 minutes, I can get rid of the odor with the 200 CFM fan. So the question, what would you use? 200 CFM fans. Fan Tech, I don't know if I have the slide for it. I don't. Fan Tech's FR150. They come up to about 350 CFM. They cost about 150, although I don't know, nowadays they're probably $250. The last one I bought was $149. I put a 260 CFM fan in my master bathroom.
The 270s are 200.
270. I put that in the plastic 270. Put that in my master bathroom. You turn the fan on, you can listen for it and kind of tell that it's on. If it's early morning, you can hear the air whistle. During the day, there's too much background noise, you can't tell the fan's on. That's how quiet it is. And it'll pull the doors because it's 200. It's moving. I just actually brought home that barometer and I tested it. Mine's moving about 180 CFM in place, installed with all the ductwork. It's nice when you take a shower, you walk out of the shower, you actually see the steam swirling on its way into the fan. 2 or 3 minutes later, it's clear.
And you can use it for your range hood too.
Yeah. Of course.
Yeah, but how do you calculate now that basically if you're exhausting all that air, have that latent heat in it? Right? And you've got, are you doing heat recovery? You're not doing
No,
anything like that. So all
it's
that is
intermittent.
going out.
It's intermittent.
So it's not a big load, at the end of the day. It's
No,
not a big load.
it's like leaving the door open while you bring the groceries in. Is it gonna waste energy? Sure. Is it worth worrying about? No. If you're using a handful of big fans, we haven't gotten to whole house mechanical ventilation, so you're gonna have to bring air in anyway. The nice thing about this for a builder is all your fans are remote in an attic or in a basement. And when the fan dies, the electrician goes in, these happen to be hardwired, but a lot of times I see them plugged in, and they just literally pull the 2 clamps, stick it in, plug it in, and go home. It's a 5-minute fix. When your bath fan motor dies, try finding a replacement motor for a 4-year-old Panasonic model, whatever. You gotta drive there, make a trip just to find out what the model number is. Then you gotta find the part, and then you gotta change it. Just swap it out, put another one in.
Or you call Tom and he will find it on the internet for you, he did that for me, to replace it.
Yes.
I don't remember.
Okay, another change, whole house mechanical ventilation. Remember those bath fans on timers that everybody was doing because I told you had to, or somebody told you had to? We make the house so tight now that there's no fresh air for the people to breathe. And that's bad. And you don't want people to get sick, you don't want sick house syndrome, so you need fresh air. And since people generally aren't very bright, they won't open a window until they suffocate. So the code says, just to save those people from themselves, no Darwinism in this world, you really need to have minimum ventilation air, what we call dilution air, that keeps the air fresh. It used to be, you could use a bath fan, exhaust it, and let it leak in. They really wanted to have ERVs, mandatory. But ERVs are about $3,000 to $4,000 installed, and in our climate, they don't save any money. Since the code is supposed to save people money, supposed to have a return on investment, it's really hard to push. So before I move on, basically they said from now on you have to have balance. They can't force you to use an ARV, but you can't use an exhaust fan. Can't use a bath fan anymore. You have to have balanced ventilation. The push was to try to make you use an ERV. I'm not a super big fan of ERVs. If you have no budget and you build a really nice house and the HVAC guys show up every 6 months to service it, they're great. If nobody looks at it again for a year or two, that thing isn't doing anything except collecting mold and wasting an amazing amount of electricity. This one is about a $1,500 unit. I'm gonna guess these are, depending on who's putting it in, $3,000 to $4,000 installed. They're about right, $3 to $4 grand installed. Maximum airflow is 150 CFM. Rated airflow is 120 CFM at 0.3 inches. You saw what I did with this duct? Same thing happens with that. If you got to route that halfway around an attic, I tested, the thing runs at 70 or 80, probably enough to pass, you're good, but you've got 2 fans pushing air through a heat exchanger. So where a regular bath fan, you get about 5 CFM per watt. So like a 100 CFM fan runs 25 watts. This is a 150 CFM unit, runs about 120 watts. It's almost 1 for 1, it's like 0.7 or 0.8. This uses a lot of electricity. It doesn't save much heat because we don't stay cold for that long. If you shut it off in the spring and fall, this would make sense. But again, that's only if people do that. If I was installing this and I could say anytime the windows are open, it'll automatically shut off, because if the windows are open, I don't need this, it would make sense. If this is running all year long, it costs you more than it saves. So they didn't require it, they just said balance. The problem is, if you want balance, that's all you can get. Only model I managed to find, Fantech makes a balanced ventilator. It's 2 fans in a box. Well, it is. It's 2 Fantech fans, one facing in, one facing out. And it's got a little control so you can adjust the fan speed so they balance. It's like $300. It moves 80 CFM. I personally just think this is a waste unless you're gonna put half a dozen of these in to get kind of volume you want. At that point, it's great for an ERV. I'm not a big fan of balanced ventilation. It's stupid. Again, it's not great, I don't know. But we don't have a choice. It's code. Here's my reasoning. The idea would be if you use a bath fan, if you have exhausting, if I'm constantly exhausting air, it's got to leak in from someplace. Where's it going to come in from? I got a leaky house, it'll come in through the walls, coming around the doors. I got a brand new airtight house. It's going to have a real difficult time coming in. It's going to leak in any holes, so it's going to blow through wall cavities, or it's going to come in through my fireplace chimney, or any place it can get in. I can't control any of that. I can't clean it. It's kind of random if I'm pulling humidity in with it, then I might be getting mold in my walls. I don't really want my house as a negative pressure. I put an ERV in, I have equal amounts going in and out. Sounds good. Equal amounts in and out, I solved the problem. But I have exhaust fan. So at the end of the day, I'm still gonna be blowing more out every time I turn a fan on. Equal doesn't do me any good. Just a little thermodynamics. Everybody heard of stack effect, hot air rises. If you look at a typical house, hot air in the house, hot air is gonna rise. The pressure at the top of the house is gonna be slightly higher than the pressure outside. It's gonna try to push out through the attic. In the basement, it's gonna be slightly lower, it's gonna try to suck it. And that's how you get that stack effect, like a chimney. There's a spot in the house called the neutral pressure plane where the pressure is the same inside as outside. Usually like on the middle of the first floor of a house, your front door leaks, but no air goes through it unless the wind's blowing. Because that's neutral, pressure outside is about the same. It's not a big deal if those windows leak. If you open a window, it might not do anything. Whereas if you open on the second floor, well, your hot air is going out and cold air is coming in the basement. The concern now is we built the house pretty tight, so those little bath fans, left out the fireplace. Fireplace, this is specifically if you have a chimney. Fireplace tends to have its own neutral pressure point because the chimney is a lot longer. The chimney has its own stack effect. So even though in theory, the opening to the fireplace might be in some place where it's lower pressure than outside, house air is still trying to leak out. Even if the damper's closed, it's still trying to go out because heat rises, it goes up that flue, which is what it's supposed to do. That's the purpose of a chimney. Now I start messing with it. I put a ventilator, it's balanced. Okay, I haven't changed anything. Then I turn on all my bath fans or my kitchen. One of the reasons you're required to have makeup air for a range hood, because if you turn on a range hood, it's just gonna pull that fireplace backwards and either pull a flame in or pull all the smell and creosote in, because that's the biggest hole in the building. Well, I decided I'm gonna go with a neutral ventilator, a balanced ventilator, so that I don't affect that. The bath fans will still affect it. I'll still be going negative every time I turn something on. What have I accomplished? When the wind blows, I have a good chance. So going balanced doesn't help me. It sounded good when we were trying to save energy with an ERV, but if I'm just gonna put in balanced, it doesn't really help at all. So my concern is backtracking. Even when it's off. When it's on, I have to worry about smoke and fire. When it's off, I have to worry about either the smell of wood burning creosote or that smell of forklift, like warehouse smell if you have a propane fireplace and the odor from the nitric acid on the walls comes back in. It smells like a forklift. If I use a positive pressure ventilator, if I just push air in, I'm always pushing air out. Where am I gonna push it out? All the vents in the walls. I got bathroom vents with flaps that open up. I've got my chimney where it can go out. Ideally, every commercial building is positively pressured. We bring outside air in, we temper it, we condition it, we filter it, we blow it into the room. The building is always slightly pressured. You get into a high rise, get into New York City, they are pumping pressure into the main floor, you never get the doors open. It's one of the reasons why they have revolving doors. Because first high rise they built, someone tried to open the door and it broke a woman's arm. Because they just did this and it slammed because there was so much suction
They just pulled the door closed and broke someone's arm. And they said, well, we gotta come up with, we need airlocks. They started putting in double doors. And then someone came up with the revolving door. You go into like a New York City, old New York City building, you open the doors, it's like a hurricane at the door. It's because hot air is going out and it's gotta come in from someplace. New buildings now, they just pressurize it. They force the air back down to keep the main floors pressurized. We should be doing the same thing with our houses, keeping them slightly pressurized. They couldn't make it code because people still use fiberglass. And the old thinking was, well, I don't want to push the moisture into the walls any more than I want to suck the moisture out in from outside. So I had the same problem, and I got mold in my walls. If you're using spray foam, or you're making the house pretty tight, it's not an issue anymore. So positive pressure is the ideal thing. Code says balance. My suggestion is going to be, did I miss a slide? No? I think I lost I lost the slide here someplace. It's not on here. The next slide should have been April 8145. Yeah.
It's in here.
Yeah.
It's in there. Okay, good. It's a fan in a box with a filter. Brings air in, pressurizes the building slightly, has its own controller, costs about $350. Problem solved. In theory, since it's supposed to be balanced, personally, I would say, well, the dampers opening balance it, but if the building department, depending on where you're building, the other option would be you use your bath fans also to get the air back out. We balance it that way. And then you never use the bath fans because it's going to blow out anyway. So again, it's another stupid code that we have to kind of make do with. At the end of the day, I can't accept bath fans because those are never balanced. They're always negative pressure. Any kind of intake air like that 8145, that will balance because the dampers will open and it'll zero out. That's how we should be ventilating. And again, I'd rather see more. You don't have to use more, you have to have more. Because if your customer calls up and says, my bathroom's just like I had a customer in Oldfield. Bathroom has stuff dripping on the walls, it's starting to get moldy, they don't know what to do. I checked with the camera, I infrared, I checked everything. Nothing was a problem. Teenager in the room, he's not using the fan. Put in a bigger fan, didn't solve the problem. Put in a moisture sensor, problem went away. Because then it didn't matter if you turned on the fan, it went on automatically, so you couldn't take steam showers anymore. The fan automatically went on and dried the room out, problem went away. If you put a big enough fan in, the customer calls me and says, my house is always stale, turn the fan on. If you have just enough fan and the house is stale, then the lawyer gets involved and says, you didn't put in the right whole house mechanical ventilation, and the house isn't safe, and it has sick house syndrome. And they call the guy with those mold swabs, who swabs a couple of walls, tells you the whole house has to come down because it's covered in mold. I had one of those too. Amazing when you call a mold guy, just how bad, I had a house that had, I think they were up at $400,000 in gutting and renovation because they found mold. The HVAC condenser, the drain cloth, and the coils got moldy. And then the guys went and swabbed every surface and took down every piece of sheetrock that had mold on it. And we live on Long Island, so it was every surface. From a CYA standpoint, more fans are better.
So you're saying this for just the bathrooms or throughout the house?
That's for the house.
The
The
house,
way,
nothing to do with the
the way
bathroom?
modulars did it won't work anymore. You won't have a bath fan on a timer. They'll be probably using an 8145. My guess is that's the cheapest, best way to do it. I don't know. I'm not sure how they're gonna do it yet. I talked to the Apex guys and they were still kind of shrugging their shoulders. Okay, makeup air. This one's a little bit misunderstood. If you have a fossil fuel appliance that is neither direct vent nor uses mechanical draft, if you have a chimney and your kitchen hood is over 400 CFM, you need makeup air. You're gonna suck out 400 CFM, you gotta replace it or it's gonna backdraft your chimney. So you need makeup air. Code is pretty lenient about it. You can just have a damper that opens up.
I can tell you that a damper that opens up never works. If you turn on the range hood, the house is gonna fill with smoke from the fireplace. I absolutely don't ever recommend just using a damper, because the same way all of this hose became a problem, the damper 30 feet away that opens up, that has to run through all of that ductwork to get to the kitchen, to the fireplace, is gonna have too much back pressure, and it's never gonna equal what the fan's taking out. The house is gonna go negative, the fireplace is gonna backdraft. They sell makeup units, makeup air. Fantech makes MAU makeup air unit is the model. They come in like an 8, a 10, and a 12-inch. You turn the kitchen hood on, it's sucking out 1,000 CFM. The other fan goes on, blows in 1,000 CFM. The Fantech ones have a heater built in, so you're not bringing in 30-degree air in the winter. That particular unit's about $1,000. You can get them without heat. You can just use a regular Fantech fan for $300 or $400. That's pretty much the only way to guarantee that the house isn't gonna fill up with smoke the first time they have a fire starting to die out and they go to cook. This is allowed, but it doesn't work. And I generally, I tell people, you have it, so you pass code, but I would really check and make sure and, light a couple fires, because you're probably gonna fill your house up with smoke. But again, I'm code enforcement, I'm not intelligent thinking, it's not my department, so I can't tell them they have to. Nice system, instead of a makeup air unit, you put a dedicated outdoor air. You can condition it, heat it and cool it on the way in. These guys they do a lot of these systems. They put, like Mitsubishi has that particular unit as a Mitsubishi. You could bring in 1,200 CFM of air at 70 degrees or whatever humidity you want, and have it drape right in front of your fireplaces. If you ever look at the fireplace calculations from the engineers, they want like 600 or 800 CFM per fireplace. They want that room with the fireplace to always be pressurized so that the fire could never backdraft. Best case scenario, an engineer's dream, it's not what people would really do, but that's what they want to see. So on the really nice houses with money's no option, we see those on a regular basis. You see a little air curtain on one of the linear register over the fireplace that just brings in air, pressurizes that room.
Is that the same criteria for like a wood stove?
Anything with a chimney, oil burner, fireplace with a chimney, metal fireplace with a chimney. If the word chimney is in there, if it's naturally drafted, in other words, like the direct vent fireplaces that go out the side wall, those don't need it. But if there's a chimney that requires hot air rising to work, like a fireplace or like an oil burner, wood burning stove, absolutely you need that. And I absolutely would recommend a good sized fan coming in, because we've seen problems. One of the builders in East Hampton, his own home, had one of those hanging wood burning, the orb looking, floating wood burning stoves. And they woke up in the middle, it was his own house. And we talked about it, and he said, well, let's see what happens. And he woke up in the middle of the night and the fire alarm's going off because somebody had turned on the bath fan, and it brought the house negative enough that it brought all the smoke in. And he ended up repainting the whole place.
We had some issues when people were first spray foaming a lot. And they'd do a kitchen renovation and spray foam, and they'd have a wolf range hood or something, or not even. And somebody had turned on the range hood, and the natural vent water heaters and stuff. And Richie Lenzer was saying that, he kept getting these complaints, and he'd go in and, the elderly homeowner was all red from CO2, carbon monoxide problem. It was really a problem.
The thing is, things that we never even considered, like a hot water heater. You used to you'd lose the boiler and just put the hot water heater back in the chimney. You had enough draft that the hot water heater worked fine. But like the heating guys, like my boiler, I put a smaller gas boiler in an old oil chimney. They're like, oh, you have to make it smaller because it's not gonna get enough draft. Worked just fine. Spray foam that house, ain't gonna work anymore.
you just don't get enough draft because you don't have enough air getting in. Suddenly you choke the thing out, you start filling your house up. There's a code compliance option for range hoods. And you'll basically buy a 600 CFM range hood, and they'll say, oh, it's got a codes compliance option. You hit the jumper, and it locks out high speed, and you get 395 instead of 600. So you pay for a 600 fan, but it stops at high speed shut off. 395 on a spray foam house, you still get a backdraft. Like, if you have a fireplace and you're putting in anything other than, a little tiny microwave, you're gonna have a problem. You really need makeup there. It just, won't happen when the fire's roaring, but it'll happen when they have a nice fire during the day, then they decide to leave it and go cook, and it's smoldering, and then they turn on the range hood, and they fill the house up with smoke. The height of the house is more of an issue it becomes. Okay, lighting. No one likes this one. Luminaires in habitable spaces have to have a dimmer or an occupancy sensor. No more light switches. You walk in the room, you can't have a light switch, you have to have a dimmer now. I think Lutron just paid somebody off for this one. This one just added $1,000 to the price of the bill.
They're the ones behind it all.
And now everybody has LEDs, so you're gonna put the dimmer on and everybody's lights are gonna flicker and no one, I don't know where this one came from, but it's code. Or automatic shutoffs, and this is for habitable spaces. This is for rooms, things, places you walk in, turn the light on. Garages, unfinished spaces, basements, those need an occupancy control. This is by design. So when you go down the basement stairs, you turn the lights on, you walk all the way across the basement, and then the light shuts off, and you can wave like this like crazy forever because the switch is too far away, and you can walk back in the dark and kill yourself. Again, I don't make the codes. They're trying to mirror commercial code. Makes sense in a commercial building. People walk out, leave the lights on. With LED lights, I don't even know if it makes a difference in the house. All the lighting in my house, I have a hot tub. I could light my house for 10 years for what that hot tub uses in a week. So I just don't know if it makes a difference anymore. Exterior lighting, daylight control and timers. You can either have a timer or you have to have daylight controls, one or the other. Can't have on and off switches.
What happens in smart systems?
Smart systems have it all built in. So that's, if you're putting in smart, like a Lutron system, or even like the Leviton smart homes, the Wi-Fi ones, you cover it. It's just back to money again. Okay, that is the end of my code presentation. This last section now is on the electrification. This is just on pros and cons, equipment specifically. So if you want to stick around, we have another 10 minutes or so.
See you in the wrap up.
All right.
That's great. Thanks, Tom.
So,
Thank you.
what I did is I kind of looked at it, electrification. We have a lot of people that are talking about going all electric. Either save the environment or because it's going to be cheaper. And I kind of ran it both ways and said, are we saving the environment? Is it any cheaper? And the answer is kind of wishy-washy. This is what I started with. This was pre-war that's not a war. So keep in mind that these numbers are absolutely not carried over the island on the ferry prices. I did get updated prices from Reed, from, what's the name of the?
Bicozzi's. We got
Bicozzi's
before the war and after war.
Yeah.
Right?
Turns out, oil is like, I don't know, diesel is just crazy high right now. It's 5 and change. Propane, however, did not really change. Propane was $3.09 instead of $2.99. It went up 10 cents.
We don't have to import it, right?
Yeah, and it's also, the commodity, oil is by barrel and it's international.
Propane is regional, like natural gas. So it's what your supplier is paying locally. So it depends on where you are in the United States, a barrel of oil is the same. A therm of propane changes a lot depending on where you are, just because a lot of it is getting it to you rather than paying for the price of the material. So these are pretty accurate. Natural gas, this was actually from November when I started doing these classes. Natural gas is now up to about $1.90, but I didn't feel like changing the number to doing all the math. Electricity is $7.62 a therm. So relatively speaking, for the equivalent of 1 therm of natural gas, a little over a gallon of propane, and a little less of a gallon of oil. In this particular calculation, I also included the efficiency of equipment. So the oil is getting 85%, it's gonna cost you $3.23 a therm, propane $3.44, natural gas $1.79. Electricity depends on the heat pump. That's the deciding factor, the COP, because it's costing me $7 and change, but I might be getting 2 or 3 to 1 for my money. That's where it turns out there's a lot of fuzzy math happening. For instance, this is top of the line variable refrigerant flow heat pump. When it comes to efficiency numbers, there's a Bosch that's about here. There's like 3 or 4, every company has their top of the line efficiency number. MXZ is one of them. COP at 47, COP is coefficient of performance. For every dollar's worth of electricity I put in, I get $3.50 worth of heat out. So if I'm paying 6 and change, divided by 3.5, I'm only paying $1 and change. Sounds like a deal. It's cheaper than natural gas. The true number, that HSPF2, that's the seasonal efficiency. Because they don't ever want to make something easy to do the math on your fingers, because then you understand they were pulling wool over your eyes. That is electricity in BTUs out, not electricity in electricity out. Not energy in energy out, they multiplied it by 3.41, whatever the BTU is, 3.415. When you divide it back out, 3.412. The seasonal efficiency is 2.89. This is a top of the line heat pump. So my $6 and change electricity, I'm getting less than 3 to 1. I'm still about $2 for the top of the line heat pump. If I had natural gas, it'd be cheaper. If I had propane, this is going to be a little bit more.
And if you had solar panels, now it really drops,
Well,
other than the fact that you paid for the solar.
But again, if I'm using, and I'm gonna get into this in a minute. Unless I have a sea of solar panels, if I'm using the solar panel to offset half of the money I would have saved if I had just used natural gas, I'm not saving any money. Like, I'm better off using the electricity for something I need electricity for than trying to use it to replace propane that's already pretty cheap. Other issue is we happen to not live in climate zone 4 that's on the books. We live in climate zone 4 on an island. You guys live on an island that's off another island, so you guys are living in the water. Wind humidity here is a lot higher than it is in Washington, DC, or
88% average.
yeah, so what ends up happening with the heat pump is those coils have to get really cold to get any heat out of the air. And if you have really cold coils, that dew point calculation we were talking about, any moisture that hits them freezes because they're ice cold. So your coils freeze up. So these heat pumps have a defrost cycle built in. So like every so many minutes, they take the heat from the house and pump it back into the outside coils to melt the ice in the train. Well, not a big deal if you live someplace dry. If you live someplace wet, they start defrosting a lot. And they start, as soon as they get some ice on them, the efficiency goes down. So that 2.8 is probably really optimistic. And that's for the best you can buy. If you buy an Energy Star one, you're just throwing money out the window. Your propane is cheaper than an Energy Star heat pump to run. Do the math. Energy Star heat pump works out to $3.34 a therm.
we said our propane was about $3.30 a therm. So my heat pump, Energy Star heat pump is about the same cost to run as propane in a good 95% propane furnace. My domestic hot water heater, that costs $8 a therm because I get maybe 90%, 92% efficiency, and I'm paying $7 and change. So if I use gas, it would have cost me, or I use propane, it would have cost me $3 and change. Because I use electric, it cost me $8 for the same amount of electricity. Same goes for ranges and dryers. Gas range, everybody talks about, oh, you save so much money going to an induction stove. Turns out, induction stove puts twice as much carbon in the atmosphere as a natural gas stove. And give me a minute, I'll kind of explain that too. And that's if you're cooking before 3 o'clock or after 7 o'clock at night. If you're cooking when people cook, dollar values are double because now we're into peak mode, and that same therm of electricity is a little over $14. This is actually old, it's now about $15.50. So that instead of paying $3 for propane, you're paying $15 and change for electricity to run your stove. Now, induction stove is about twice as efficient as a gas stove because there's less waste heat, more of it gets into the pan. So you're only really paying $7 or $8 instead of $3. So you're only paying a little more than twice as much, not 4 times as much. You're saving money. The break even on a heat pump is a HSPF, heating seasonal performance factor of 10. And like I said, that is top of the line heat pump. Basically anything worse than that, any just decent heat pump, isn't saving you any money if you have propane. Save you money if you have oil, won't save you any money if you have propane. If you have natural gas, all bets are off. There's no good reason to have a heat pump. I have this little cost calculator. It's a great thing when somebody starts giving you a hard time. Again, shoot me an email, I'll send you all 3. You put in what you're paying for oil or what you're paying for fuel, what efficiency your equipment is, what efficiency you would have been putting in for a furnace or a boiler, and it'll tell you what the 2 costs are. Thank Tyler. Best option, if your customer really wants to go green, is dual fuel. Take the furnace you were going to put in anyway, or the boiler you're going to put in anyway, and put it in anyway. And then just, instead of putting the air conditioning coil and an air conditioning compressor, swap out the compressor for a basic heat pump compressor. So when it's kind of cold out, down to say 30 degrees or so, the heat pump saves you money because it's cheaper to run than fossil fuel. They run really efficiently when it's warm out. They make great heat when it's hot out. When it gets cold out, not so much, but that's when you switch to propane. The advantage to this also is when the power goes out, I don't know, how's the power grid on the island? So how often does it go out?
Not as often as Maine.
Yeah. The difference is, the difference is, if your power goes out and you have dual fuel, you get the Briggs and Stratton generator out and you backfeed your grid, your house, or you start up your little generator outside. And I can power my boiler with a battery. I'm literally looking to add a plug. I'm going to add a separate jack so that I can put one of those little battery packs to run my boiler when the power goes out. I have all this solar, but power goes out, I lose everything because I don't have batteries. If you have a heat pump, now you need a generator big enough to start the heat pump. And if you have a handful of heat pumps, you need power shedding, you need load shedding, so that when you go to turn a light on or go to turn hot water on or something else, it knows to shut the heat pump off and move the electricity around. So the cost of getting this to work in a power failure ends up outweighing any savings you do to an all-electric house. There's a project on Ram Island, Little Ram Island maybe, that massive house, all electric. I forget,
Is that 30,
I'm familiar.
Little Ram Island, yeah,
34 maybe? Big glass, a lot of glass.
big, yeah, a lot of glass,
Yeah.
all electric. They had half a dozen instant electric water heaters.
That's the one that originally was supposed to have like 24 inches of blown-in cellular.
Yes, that's the one.
Which would have caused mold within the
Yeah,
first 3 months.
that was the first spreadsheet. At the time, I had an engineering student working for me, and I talked to him, like, you gotta make me a psychometric graph spreadsheet, which is just the math on that, because the calculus involved in getting the graph to work, it only works in a really small range. So we went through it a handful of times, we came up with this calculator, and we showed up with it on the phone, and she was plugging it in, and finally, the insulator's going, spray foam! And the architect's going, more Roxel!
It's Bill Ryle, who's
I didn't want to say
he's
anything.
a true believer, you know, and.
So we ended up, they put Roxel in the walls, that much, and they put spray foam in most of the roof, because we just couldn't make it work without it.
And yet the house was almost all glass, so it was completely inefficient anyway. So it was all a charade.
And if you look at the electric, when I was there, everything was on, and they said they couldn't put in a bigger range hood because they couldn't put a bigger electric heater on the makeup air because they ran out of panel. I think they had 1,600 amps.
Yeah.
1,200 or 1,600.
I think 1,600.
They ran out of panel.
It was 400 amp
Yeah.
panels, yeah.
So, and then as I'm leaving, I'm like, it looked like a scale for a tractor trailer. You know, like the big concrete pad that you tractor, they're like, oh, that's for the generator. Wow. That's what happens when you have a big electric house. You need a big electric generator. Dual fuel. You can do it with a furnace, or you can just use a boiler and put a hydrocoil. Fan goes on, blows hot air through the hot water coil. The same way we're doing it for air conditioning, only with the heat pump. The only difference then is your thermostat has one extra setting that decides when to switch one off of the other. They really work nice. Most of the high-end heat pump systems and geothermal systems have these in there. I'm sure like every system these guys do.
It's
have
just
these
nice having that backup.
It's just a backup. And what's really nice is if it's a summer house and they want to show up in the winter, on Friday night, they decide they're gonna go in, you fire up the 400,000 BTU boiler, the house is warm in 30 minutes. You fire up the 8 tons of heat pump, and 36 hours later, the house catches up. You know, you're either dumping 140-degree air in or 95-degree air in. It's, if you're looking to get it done quick, a big-ass boiler works way better than perfectly sized heat pumps. Having both really makes, having a perfectly sized heat pump is great, but.
What it is, it's just, people want heating and cooling,
Yes.
right? So that's the problem. Heat pump solves both things in one sort of device, right?
But
The person put the boiler in and putting.
this is the thing, they also want hot water. So let me just get through this. We do the curves for where the point that usually this is with oil heat, and this was for oil heat and an Energy Star heat pump. The trade-off, the point where it got cheaper to use oil was 30 degrees. 30 degrees is the average winter temperature. So 50% of the time you'd be on oil, it would be cheaper. That's what an Energy Star. If you get into putting in like a real high-end City Multi or an MXZ or a Bosch M20, suddenly that goes down to like 10 degrees and it almost doesn't pay you. You'd never use oil with that. It'd just be cheaper to run, but you still need hot water. Standard hot water heater. By the way, new code requirement, anything bigger, I believe it's 45 gallons now, it's 55. We don't see very many electric hot water heaters. If you put in a 75-gallon water heater, it has to be demand response ready. It has to have that little computer control that lets LIPA turn it down, because it uses so much electricity that in the summer, if the hot water heater kicks on, you blow the grid up. They're 4,500 watts. The thing is, 4,500 watts is 15,000 BTUs. That is a 15,000 BTU recovery on your water heater.
And it doesn't really matter what size electric heater you put in. They pretty much all have the same size coils in. So if you get 80-gallon water heater or 120-gallon water heater, you'll have more storage, but it'll take that much longer to heat up because you still only have 15,000 BTU. If I put in a gas 75-gallon, it's 75,000 BTU. So my recovery is 5 times faster on a gas 75 than an electric one. The Navi and Instant, those are 200,000 BTU. That's how much heat you need to get instant hot water enough for one shower. You need 200,000 BTU. These are those electric instants. This one is a 36 kW, 122,000 BTU. So it's instant, but it's not even, it won't even run as much as one of those Navians would. So you probably need 2 of them on a decent sized house, 3 or 4 for a big house. They require 4 40-amp breakers, 2 pole breakers. So it requires 150 amps each to run. Now, keep in mind that you're paying $7 and change compared to that $3 for Pro. So you're paying twice as much to run these electric heaters that you need to upgrade your service. Like they suggest a minimum 300 amp service to use one of these. If you're having 2 of these, you probably need a 400 amp service. And if you have more than 2 of these, you need load shedding, so they shut off when something else tries to turn on, because these are running all the power for your house. This is sucking all the power out of the panel that you can get. You know, that 80% capacity, 2 of these things will kill it. Heat pump water heater, super efficient. They are 2 separate hot water heaters built in one. The bottom is a regular electric water heater, same 4,500 watt element, 15,000 BTU. The top is a little Mickey Mouse toy. It's 4,200 BTUs. It's this little tiny compressor. Doesn't matter if you get an 80-gallon, a 40-gallon, or a 30-gallon. 4,200 BTUs will take, fill a 50-gallon tank, it'll take at least 10, 12 hours to heat it up. So basically, whatever size tank you have is as much hot water as you have. They're useless for a summer home, because if people are gonna all show up, I just lose my sound?
Yeah.
Oh, well, I could yell, battery probably went dead. They're useless in a home where people are gonna all come back from the beach and wanna shower, because you're gonna get 1 or 2 showers and then you're out of hot water till the next day. If you don't have the load, these are great, 4,200 BTU, you take showers in the morning, by the next morning you have showers again. And you can get, my recommendation would be biggest tank you can get. Same tiny little toy compressor, 80-gallon tank, at least you get twice as much hot water for the day before you run out. They make them bigger. This one's 42, this one's 75. It's a split system, the compressor goes outside. Sanko makes a 15,000. We're still talking about, this big one, this Sanko, this is like I think it's like a $7,000 or $8,000 system, kind of like an indirect tankless setup. This thing's still putting out as much as your little 30-gallon electric. It's still 1/5 of what your 75-gallon gas heater put out for recovery time. So they're still kind of toys. If you're using these, you gotta rely on massive gallons of storage to be able to have enough hot water. Biggest one, I think it's just available now from Mitsubishi. It was only available overseas. They're importing it now. This one is a 20-ton unit. It's the big Mitsubishi City Multi hooked up to a 120-gallon water tank. 20-ton air, but 20 tons, if you do the math, is only, what does that work out to, times 12, 240,000 BTU. So this is the same output as that Navi and wall hung. So you're buying an 18,000, what does a city multi cost? 15,000, 18,000, instead of a $2,000 Navi. One of the reasons I say dual fuel, and you say, well, you got heat and hot water from from, you get heating and cooling from the heat pump, but you don't get hot water. So if you're gonna put in a hot water heater, put in a combi, and now you have both. Take the money you spent on the combi boiler and downgrade your heat pump from that MXZ or the top of the line to a basic scroll compressor. Save a lot of money on the heat pump, use it to buy your boiler, you end up with the best of both worlds.
Even like last winter, a lot of people were running into issues with, even with the hyperheats, with the temperatures not keeping up. And it was nice to have that supplemental backup heat, because even the heat pumps, the higher rated ones, just weren't keeping up.
They don't keep up, and you get into they would keep up under ideal conditions, meaning all the doors are closed. But then you cook and you turn on that 1200 CFM range hood, or you open the doors because it's the holidays and you're bringing people in the middle of the winter, especially like, summer houses where big crowd for a week. Well, then you don't have enough heat, and it takes so long to recover because it's sized to just barely make it when it's cold out. With a boiler, it's sized for hot water loads, which are 10 times what your heating loads are. You have 200-300. We have a lot of houses that'll have 1 million BTU of boiler, and they have 320-gallon hot water tanks. And they don't even need it for heat. They don't need any of it. They could use, one of those on low will run the heat the whole house, but they want the hot water recovery. Because if you have 10 showers and you want people to just go in and shower one after another, you need massive amounts of hot water. You need a lot of BTUs to do it. So, options for heat pump, if you really want to go all electric, bank them. If you go all electric to save the world and you put in instant hot water heaters, you have undone everything you did by going electric. That instant hot water heater is generating twice as much carbon because someplace or another, a power plant is making that electricity. And, and if you said, well, I'll put solar on, you're not powering a 160 amp electric hot water heater with solar. That's 20 kW with solar pretty much running continuously to give you hot water for those hours. Okay. Now the carbon side. I'm kind of a skeptic when it comes to these things, the saving the world. And okay, I could save money. That would be enough for me. Turns out I'm not saving the money. Now, am I saving the world? So I looked at New York ISO, Independent System Operator. You can check online. They will show you the electric usage coming out of every power plant, 5-minute intervals, all year long. You can download the spreadsheets every 5 minutes of the entire year for as many years as they go back. This was from November 17th, last year. Turns out half of our electricity comes from fossil fuels, half of our electricity comes from non-fossil fuels. I'm not going to say renewables because a lot of it's from nukes. If you can read that, I don't know if you could see it, 18% from nukes, 17% from hydro, 11% from wind, 3% from other renewables. Other renewables is all of the solar and all of the garbage. All the cogen plants that burn garbage, like Coventa. Solar ends up being like a little over 1% of our energy. And this is at 10 a.m. in the middle of the winter. This is not during air conditioning season when we use a lot of electricity. So this is kind of best case. We're at about 50-50. Half fossil fuel, half not. I kind of checked absolute worst case, and if you look, this is February 4th at 20 minutes or 10 minutes after midnight. We're still using more fossil fuel than we are renewables. Remember, solar only was 1% overall, so it doesn't really matter if it's at night or during the day. Solar is so incremental. But everything else, including hydro and wind, we're talking about less than half. So if you look at this from a am I saving the world standpoint, if I plug in my toaster, there isn't a wind generator that suddenly turns on to power it. Think about it like a generator. You plug a tool into a portable generator, you hear that thing go whir as it kicks up. Well, every time I plug something in, something kicks up. It's infinitesimal because there's so many things and it's such a big generator, but it still has to kick up. The waterfalls don't fall faster. The wind generators don't spin faster. Sun doesn't get any brighter. The nukes are already running full out. The only thing that can happen when I plug a new toy in is some gas generator someplace is going to fire up for it. So it's one thing if we say, well, you know, we're using this to replace like a car, where, you know, I'm using gasoline, it's really inefficient. But I'm using it to replace a gas boiler that was already just as efficient from a money standpoint, not saving anything. And now I'm dumping 100% of the carbon because it really, I'm running it on fossil fuels. If it isn't more efficient than gas was, I'm putting more carbon in the atmosphere than I would have. That electric hot water heater is going to be, you know, several times less efficient from a carbon standpoint than a natural gas one is hanging off the wall. It absolutely doesn't make any sense. Start adding in your gas dryer, your gas stove, all of the things that you pay double for because you want to run them when people are home, you know, because you don't want to cook in the middle of the night. It starts making more sense to stick with gas and supplement with electric. You know, my recommendation is you put solar on the roof and you use it to replace your electric loads. And if you had any more than that, get a plug-in hybrid and use it to replace some of your gasoline. Those are the things we already know run really inefficiently. Gasoline engine is 20% efficient. My gas boiler is 95%. I'm not wasting any. You know, get rid of the waste first. If you start looking at it as well, but I can use electric because I have solar, I want to find the best thing to use it for, not the worst thing. You know, resistance anything, resistance heat, resistance hot water is the least efficient way to make hot water compared to natural gas where it's super efficient. Our grid is 30% efficient. Here's the math. Our grid on Long Island, 30% efficient. Shelter Island, I'm going to guess the grid's probably closer to 25% because you're at the furthest end of Long Island and you've got another set of substations and, you know, I don't know offhand. On average, Long Island's 30%. I would think the furthest you are away from big, you know, from the big transmission lines, you know, the lower your percentage is going to be. The guy who lives under the LIPA lines probably has the best ratio. So heat pump.
We don't have a substation here, so we're running lower voltage coming in.
Oh, so yeah.
So we're.
I stand corrected. You're not even at 25%.
Yeah, we're about maybe.
Yeah. You guys are just slightly better than running a Briggs and Stratton in your backyard.
Yes.
Much more voltage drop.
Yeah. So, Energy Star heat pump. I'm at 68% efficiency. That's what it works out to. Assuming that they're running from a natural gas power plant, my end result from an Energy Star heat pump is 68% efficiency compared to the 95. You know, my house has an 80% boiler. I have the one that Brooklyn Union gave me 25 years ago. It's still cheaper and more carbon efficient for me to run my old cast iron chimney boiler than it is for me to switch to heat pumps. Unless I'm willing to go for the top of the line heat pump, and then I would just it operate heat. It's a real hard sell. 10.8. We're talking about the other one being a 10. You need a 10.8. The only ones you can get right now at a 10.8 are ductless. Ducted systems aren't that efficient because the fan wastes too much energy. So there's no break even on heat pumps. Induction range, 85%. With the grid efficiency, you're at about 26%. Gas stove is about 45%. So I'm still twice as efficient to run a gas stove. And another pet peeve of mine, everyone's like, yeah, but you're putting so much contaminants into your house. Think about it. When you cook, do you ever say, wow, the house smells like gas? You cook bacon. Do you smell gas? You smell bacon. All of that oil, is a volatile that gets vaporized into a gas and gets into the air. All those contaminants are the food, not the gas. If you cook with natural gas versus cook with electric, your contamination goes from 80 particles to 70 particles, not to 0, because most of the particles are coming from the food, not coming from the gas. And then they came up with this invention. They said we could put this thing over the top with a fan in it. And at that point, if you're trying to keep the house clean, you're going to turn the fan on anyway. And if you turn the fan on anyway, it makes absolutely no difference whether you're using natural gas or propane. As long as you're not cooking with coal, you're probably okay. So, from an efficiency standpoint, I can't find any good reason to go all electric. There are plenty of things to do in electric. I mean, I'm really big on hybrid cars. Hybrids, Prius, the most efficient vehicle, the most carbon efficient vehicle on the road today is a Prius that doesn't plug in. When you plug it in, you waste more carbon than if you ran it on gasoline. Just works out. I had to do the math for a class project some years back.
It's the New York City fleet. New York City's fleet is all hybrid Prius.
Yeah, I rented, my truck died. I run my truck on E85 so that I could say I'm green. Run on alcohol instead, and it's also $2 a gallon instead of $4 now. But my truck died. I was renting a Jeep that plugged in, a plug-in hybrid. I plugged it in. I got 24 miles before the electricity ran out. When I got home, I did the math. Turns out it would have been cheaper to put gasoline in. I wasn't saving anything by running a hybrid, and that car weighs so much extra because of the bigger battery that it gets worse gas mileage all the way around. I would have been better off just having a hybrid that didn't plug in. That's the most effective vehicle on the road, most cost-effective, carbon-efficient vehicle. It's not cost-effective, but carbon-efficient vehicle was a Prius, not a Tesla, not an all-electric. The electrics are much worse because the grid is so bad, at least on Long Island. That's kind of my feeling on it. Okay. And I see this all the time, and there's so many different things on it, but it's always true. It's just, we're not really doing anything. Nobody's ever willing to do it right. Everyone just says, well, I'll go green. Yeah,
You kind of hit on the life cycle. It's a whole other conversation.
Yeah.
Life cycle is
And even then, you can take that so far into the weeds, when you're all done, we should live in huts. Because anything we do, all right. Folks, thank you for coming. Thank you. If you have any other questions, you have my emails are on there. My recommendation, the Build Better book is a contractor guide. It's free. New York State, NYSERDA puts it out. I can email you a copy or I can send you a link. Actually, if you email me looking for them, I'll just hook you up with a Google Drive that has all of this stuff in it. Residential energy is kind of it's the textbook that raters use for, it's a good, really well-rounded explanation of everything energy related. Big picture stuff, house stuff. It's kind of a good read. Cold climates, this is my Bible. As far as I'm concerned, every architect should have this. This is every bit of math, every bit of explanation on building walls, building differently, building right for energy on the whole north end, cold climate. These guys, I've been up his place, his house is in Massachusetts. He uses it as a test center. He does an expert session. I went up, made believe I was an expert. And you spend 3 days of him kind of explaining things with amazing clarity. Then you go back to his house to see the 2-foot thick walls. And his thing is, oh yeah, they say this won't give any condensation. Let's build a dozen of them and see what happens. So they kind of destructively test things. They build little sheds all over the place. They just do on a regular basis. He's like, oh, we just tried this 6 different ways.
to see what would happen. I trust his results. This is where you find out that, oh, maybe the code was kind of stupid. Maybe the code was a little.
YouTube videos around, and his daughter
Yes.
has like online training.
Yes.
It's funny, yeah, I saw her and I was like, wow, she knows almost as much as.
He's also,
I didn't realize it was his daughter.
he's also really interesting to listen to. I've watched a couple online where he literally had architects coming over the desk at him. Like, literally, guys coming over to attack him because he's talking about lead and he did the math. He does a great explanation. He starts off with a stone rubble church from like 3,000 years BC, and he gives the R value of the building. It's like an Irish rubble.
R1.
R1.
Yeah.
And then he goes all the way through, and he goes to a LEED Platinum building in New York City.
Glass, all glass.
R1.
And 3,000.
Yeah, and he goes through like all of the ways we build, and he comes back to LEED Platinum, the best, R1, all glass building. Yeah.
But they have a bicycle rack, so.
Yeah, maybe. Think of how much carbon they save with that bicycle rack. Thank you. And.